Out there, in the cold and quiet dark, two silent ships are sailing. They are the farthest things we have ever sent from home, twin vessels named Voyager, now drifting on a sea between the stars. Have you ever wondered about their journey? How long can a creation of human hands endure in the vast, patient emptiness of the cosmos? What will become of these messengers, long after we are gone? Tonight, we will wander through these questions together, not as a challenge to be solved, but as a quiet story to be heard. But first, allow yourself to settle in. Find a comfortable position, a place where your body can feel at ease. Notice the gentle weight of the blankets and the softness of your pillow. Let the day and all its concerns begin to fade, like distant stars in the morning light. Before our journey begins, I would be so grateful to know where you are listening from tonight. If you feel inclined, you can share your city or country and what time it is for you in the comments below. It's a lovely way to feel connected in this quiet moment. We begin our story now with these two remarkable travelers by simply finding them in the dark. Imagine, if you will, the vastness of our solar system. Picture the sun, a brilliant, burning heart, and the familiar planets tracing their silent, looping paths around it. We know these worlds: Mercury, Venus, our own Earth, Mars, the great giant Jupiter, and the ringed beauty of Saturn. We can picture Uranus and Neptune, the distant ice giants. And even farther still, the lonely dwarf planet Pluto. For most of our lives, this has been the map of our cosmic home. But our journey tonight takes us far beyond these familiar landmarks, out into an emptiness so profound it is difficult to truly comprehend. It is here, in this deep and quiet space, that the Voyager probes are sailing. Launched in the year 1977, Voyager 1 and its twin, Voyager 2, have traveled for nearly half a century. They have flown past worlds we had only seen as faint points of light, and they have sent back pictures that rewrote our understanding of the outer solar system. But their primary mission, their grand tour of the planets, has long been complete. Now, they are on a different kind of voyage, an interstellar mission, one with no final destination in mind, to feel where they are now. Let us measure the distance not in miles or kilometers, but in the speed of light itself. A ray of sunlight takes a little over 8 minutes to reach us here on Earth. That same light takes hours to reach the orbits of Neptune and Pluto. But a signal from Voyager 1, traveling at the fastest speed the universe allows, now takes nearly a full day to reach the deep space network antennas on Earth. Think of that for a moment. The message we received today was sent from the probe yesterday. There is a delay of almost 24 hours, a profound gap in conversation that speaks to an almost unimaginable gulf of space. Voyager 2 is not far behind, its own signals taking just under 20 hours to cross the same immense distance. They are more than 15 billion miles from the Sun, so far away that our star, the center of our world, would appear as just a particularly bright, unwavering star in their sky. It would offer no more warmth than any of the countless others scattered across the blackness. This is the first truth of their journey. They are profoundly alone, sailing in the dark. They left our shores so long ago and have traveled so far that they have crossed a fundamental boundary. In 2012, Voyager 1 became the first human-made object to enter interstellar space. Its twin, Voyager 2, followed in 2018. They have left the nursery of the solar system and have entered the vast, open galaxy. They are no longer just planetary probes. They are now our first true emissaries to the stars. And so, as we settle into our own quiet spaces tonight, we will join them there, on the very edge of everything we have ever known. We will feel the profound silence of their location, the immense and patient journey that has brought them to this place. And from this serene starting point, we will begin to wonder about the long, long road that still lies ahead of them. A journey that will be measured not in years or decades, but in the slow, deep time of the cosmos itself. Let your mind drift into this quiet emptiness, feeling the peace of such a grand and lonely distance. Having found the Voyager probes in the deep darkness, let us now gently turn our attention to the boundary they have crossed. It is not a wall or a line drawn in space, but an invisible shifting shore that marks the true edge of our sun's domain. This frontier is called the heliopause, and understanding it is key to understanding the new ocean upon which the Voyagers now sail. For all its apparent emptiness, the space within our solar system is filled with something, a constant, flowing river of particles streaming outwards from the sun. This is the solar wind. It is a tenuous, superheated gas, a plasma that blows from the sun in all directions, traveling at hundreds of kilometers per second. This wind creates a vast protective bubble around our entire solar system, a bubble known as the heliosphere. You can think of it as the sun's breath, extending far beyond the outermost planets, creating a sheltered space in the galaxy. Inside this bubble, the environment is dominated by our star. The particles, the magnetic fields, everything is shaped by the sun's presence. But the galaxy too is filled with a thin medium of its own, the interstellar medium. This is the sparse collection of gas and dust that exists in the vast spaces between the stars. And so, out in the far, cold darkness, these two winds meet. The solar wind, having traveled so far, grows weaker and more diffuse. The interstellar wind, the collective breath of countless other stars, pushes back. The heliopause is the place where the outward pressure of our sun's wind finally comes into balance with the inward pressure of the interstellar medium. It is a quiet, invisible shoreline where the influence of our home star gently gives way to the influence of the galaxy at large. For decades, the Voyagers journeyed within this bubble. They were always within the sun's sphere of influence. But as they traveled farther and farther, the instruments they carried began to report subtle changes in their environment. They detected a slowing of the solar wind, a sign that they were approaching the boundary region. Then, in 2012 for Voyager 1 and 2018 for Voyager 2, a profound shift occurred. The probes detected a sharp drop in particles from our sun, and at the same time, a dramatic increase in high-energy cosmic rays from the galaxy outside. They had passed through the heliopause. They had left the harbor and had sailed out into the great, deep ocean of interstellar space. Imagine standing on a beach, feeling the gentle breeze coming off the land at your back. You can walk to the water's edge, and for a moment, you can feel that land breeze still. But as you wade deeper, you begin to feel a different wind, a cooler, steadier wind coming from across the vast ocean. The heliopause is like that meeting point. It is not a violent collision, but a soft and gradual transition. The Voyagers have now waded deep into that new water, and the wind they feel on their sails is no longer the wind of our sun, but the ancient, patient wind of the Milky Way. This crossing was a silent, momentous event. It marked the end of one journey and the beginning of another, much longer one. The probes are now travelers in a new and different realm, a place governed by galactic forces, a place we are only just beginning to understand. Thanks to the faint whispers they continue to send back home from across that quiet shore. Now that we have pictured the Voyagers crossing that invisible shoreline, let us pause and listen. The probes are not truly silent, even now. They still speak to us, sending faint signals across the vast emptiness. And within those signals, within the data from their instruments, is a kind of music, the sound of interstellar space itself. Of course, space is a vacuum, and sound as we know it, a vibration traveling through the air, cannot exist there. But the space between the stars is not a perfect vacuum. It is filled with a very thin, electrically charged gas called plasma. And just as waves can travel across the surface of a pond, waves of energy can travel through this cosmic plasma. The Voyager probes were built with instruments designed to detect these plasma waves, to measure their frequency and density. On Earth, scientists can translate these measurements into audible sounds, creating an eerie and beautiful soundtrack of the void. For years, as the Voyagers traveled through the outer reaches of the heliosphere, the plasma wave instrument detected the gentle hum of our sun's influence. It was a relatively quiet environment, the familiar sound of home. But as Voyager 1 approached the heliopause, the boundary to interstellar space, it began to hear something new. It detected a sudden and dramatic increase in the density of the plasma around it. The space outside the sun's bubble was much thicker with this material than the space inside, and this denser plasma could carry waves more readily. In 2013, a powerful solar flare, a great burst of energy from our sun, erupted and traveled outwards through the solar system. Months later, this wave of energy reached Voyager 1, which was by then already in interstellar space. The wave struck the dense interstellar plasma and caused it to vibrate, to ring like a bell. For the first time, humanity could hear the sound of the interstellar medium. The pitch of this ringing sound was directly related to the density of the plasma, and it confirmed, without a doubt, that Voyager had crossed the boundary. The sound was higher in pitch than anything the probe had heard inside the solar system, a clear note signaling a new environment. Since that time, the instrument has continued to listen. It has heard the gentle, persistent hum of the undisturbed interstellar plasma, a constant, low drone that is the baseline sound of the galaxy in our quiet corner of space. It has also heard the echoes of other, more distant events, shockwaves from stellar explosions that happened long ago and far away, still rippling through the medium. To listen to these translated sounds is a deeply meditative experience. It is not a symphony of crashing cymbals and loud fanfares. It is a subtle, minimalist composition. It is the sound of profound emptiness, punctuated by the faintest of whispers. Imagine sitting by a still, quiet lake in the deepest part of the night. You might hear the gentle lapping of the water, the almost imperceptible hum of the air itself. Then, a stone is dropped far away, and much later the faintest ripple reaches you. That is what the Voyagers are hearing. They are cosmic listeners, floating in the quiet, patiently recording the vibrations of the void. And the data they send back, this sound of space, reinforces the serene and immense nature of their journey. They are no longer just seeing the cosmos. They are hearing it. And this faint, ethereal music is the soundtrack to their endless voyage, a constant reminder of the vast, deep, and patient universe through which they now travel. A universe that is not empty, but filled with a quiet, resonant energy. As we continue to drift alongside the Voyagers, hearing the subtle sounds of the void, let us now consider their view. Let us imagine what they see when they look back in the direction from which they came. For us here on Earth, the sun is a life-giving furnace, a brilliant orb that dominates our sky. It is the anchor of our world, the source of warmth and light. Its presence is so overwhelming that it is difficult to imagine a perspective from which it is not the most important thing in the sky. But from Voyager's vantage point, billions of miles away, this is no longer true. From the deck of Voyager 1 or 2, the sun has shrunk. It is no longer a disk, but a point of light. It is still magnificently bright, far brighter than any other star in the sky, but it is a star nonetheless. It has lost its character as a nearby, personal sun, and has taken on the aspect of a distant, impersonal star. It can no longer warm the spacecraft. The ambient temperature in interstellar space is just a few degrees above absolute zero, the coldest it is possible to be. The Voyagers must rely on their own internal warmth to survive, a topic we will gently explore soon. The sunlight that reaches them is weak, a pale and distant echo of the brilliant light that bathes our world. If there were eyes on board the spacecraft, the view would be one of breathtaking, crystalline clarity. With no atmosphere to blur the view, the stars would not twinkle. They would be sharp, steady points of diamond-like light against a backdrop of perfect, velvety black. The Milky Way would stretch across the sky, a brilliant river of light more vivid and detailed than any view from Earth. And somewhere in that glittering starfield would be our sun, a bright but lonely beacon marking the location of home. This change in perspective is a profound and peaceful one. It is a visual representation of the journey the probes have undertaken. They have traveled so far that their home has become just one of countless other lights in the cosmic darkness. This is a humbling and serene thought. It gently removes us from the center of the story and places us within a much grander context. The probe's journey is no longer about leaving home, but about joining the community of the stars. In 1990, when Voyager 1 was about 4 billion miles away, it was commanded by the mission team to turn its camera around one last time and take a final picture of the solar system. The result was the famous pale blue dot image, showing Earth as a tiny, fragile speck of light in a vast sunbeam. Now, decades later, and many billions of miles farther, that dot would be entirely invisible. all the planets of our solar system would be lost in the glare of the distant sun. The Voyager probes have sailed so far that their home is no longer a place they can see, but only a place they can remember, a place from which a faint radio signal still connects them to their creators. And so they drift on, no longer looking back, but forever facing forward into the endless starry night ahead. We have touched upon the immense distance to the Voyager probes, but let us now rest with this idea for a moment longer and feel its full weight. We often speak of space in terms of physical distance, miles, kilometers, astronomical units. But a more intuitive way to feel the separation is to think about it in terms of time. The speed of light is the ultimate speed limit in the universe, the fastest that any signal or piece of information can travel. As we've noted, a message from Voyager 1 currently takes nearly a full day to reach us. Let's gently unpack what this means. When the scientists at the Deep Space Network send a command to Voyager 1 telling it perhaps to recalibrate an instrument or to shift its orientation, that command travels for about 23 hours through the void. The spacecraft receives the instruction, performs the task, and then sends back a confirmation signal. That return signal takes another 23 hours to come back to Earth. The total round-trip conversation time is nearly 2 full days. Imagine having a conversation with a friend where you must wait 2 days to receive a reply to your every sentence. This is the patient, slow-motion dialogue that the Voyager mission team has been engaged in for years. It is a process that requires immense foresight and a calm, meditative patience. This time delay creates a profound sense of isolation. The Voyagers are not in our present moment. The data we receive from them is a snapshot of their environment as it was a day ago. They are living in our immediate past. And from their perspective, we, their creators, are living in their future. When they send a signal, Earth will not receive it until tomorrow. This temporal gap is a more poignant measure of distance than any number of miles. It is a distance measured in heartbeats, in sunrises and sunsets, that must pass before a message can complete its journey. This also means the probes must be incredibly self-sufficient. There is no real-time control. If an unexpected problem were to arise, the probe's onboard computers would have to handle it alone. The engineers on Earth could not intervene until long after the event had passed. The probes are, in a very real sense, on their own, guided by the programming we gave them decades ago and the long, slow commands that bridge the gap of light hours. This reliance on autonomy fosters a sense of peace. There is no urgency, no frantic back and forth. The relationship between humanity and its farthest messengers is one of trust and patience. We send our thoughts out into the darkness, and we wait, calmly, for the echo to return. As we rest here tonight, we can feel that immense, time-filled gap. We can imagine the faint radio waves of Voyager's signal, right now, streaming toward Earth, having left the probe yesterday morning. They are crossing the orbits of the outer planets, passing through the Kuiper Belt, nearing home. The journey of that signal is itself an epic voyage across a vast and silent sea. And as we prepare to consider what powers these lonely travelers, we can hold this sense of serene temporal distance in our minds. It is the true context for their journey. A journey so long that it is not just measured in space, but in the slow, steady, and patient passage of time itself. We have located the Voyagers in the vastness and felt the immense distance of their journey. Now, let us turn our gaze inward, to the very heart of the probes, to understand the source of the faint warmth that has kept them alive for so long. Far from the sun, in the deep and frigid dark of interstellar space, solar panels would be useless. The light that reaches the Voyagers is thousands of times fainter than the light that falls on Earth. To survive and operate in this endless night, the probes needed a different kind of power, something internal, reliable, and incredibly long-lasting. The answer was a gentle, persistent warmth generated by the slow, natural decay of a radioactive element, plutonium-238. Each Voyager spacecraft is equipped with 3 of these power sources, known as radioisotope thermoelectric generators, or RTGs for short. These are not nuclear reactors. There is no fission, no chain reaction. The process is far simpler, calmer, and more elegant. Imagine holding a stone that has been left out in the sun all day. Even after the sun has set, the stone continues to radiate a gentle warmth. The RTGs on Voyager work on a similar, though much more powerful, principle. At the core of each generator is a collection of ceramic pellets containing plutonium-238. This specific isotope of plutonium is highly unstable, and its atoms are constantly in a state of decay, breaking down into simpler, more stable elements. Each time an atom decays, it releases a tiny burst of energy in the form of heat. With billions upon billions of atoms decaying every second, the plutonium fuel becomes very hot, glowing with a steady, dull red heat. This heat is the foundation of Voyager's power. The genius of the RTG lies in how it converts this heat directly into electricity, without any moving parts. Surrounding the hot plutonium core is a delicate latticework of devices called thermocouples. A thermocouple is a simple, remarkable device made by joining two different types of conductive metals together. When one side of this junction is heated and the other side is kept cold, a small electric current begins to flow. It's a physical phenomenon known as the thermoelectric effect. In the RTGs, the inner side of the thermocouples is heated by the decaying plutonium. The outer side is exposed to the freezing cold of deep space. This vast temperature difference between the hot core and the cold vacuum is what drives the steady, silent flow of electricity. This method of power generation is incredibly reliable. With no moving parts to wear out or break down, an RTG can continue to produce power for decades. At the time of their launch in 1977, the three RTGs on each Voyager probe produced a combined total of about 470 watts of electrical power, enough to run a few bright incandescent light bulbs. This may not sound like much, but through careful and efficient engineering, it was more than enough to power the spacecraft's computers, its scientific instruments, and its radio transmitter. For nearly half a century, this quiet, steady process has been the heartbeat of the Voyager probes. The gentle, predictable decay of plutonium has provided the lifeblood of electricity that has allowed them to complete their grand tour of the planets and to continue their journey into the stars. It is a warmth that comes not from a fire, but from the very heart of matter itself, a slow and patient release of ancient energy that has made this entire, epic journey possible. As we continue our exploration, we will see how the very nature of this power source also dictates the eventual peaceful fate of these incredible machines. Having understood the source of Voyager's power, the gentle warmth of decaying plutonium, we now come to understand its limits. The process of radioactive decay, while long-lasting, is not infinite. It follows a calm, predictable, and unwavering law of nature known as half-life. This principle governs the lifespan of the probes and dictates the slow, graceful fading of their vitality. The half-life of a radioactive element is the time it takes for half of its atoms to decay into a more stable form. For plutonium-238, the fuel in Voyager's RTGs, the half-life is 87.7 years. This means that 87.7 years after the Voyager probes were launched, half of the original plutonium fuel will have decayed, and the RTGs will be producing only half of their initial heat. Consequently, they will also be producing only half of their initial electrical power. This is not a sudden failure, but a slow, steady, and perfectly predictable decline. It is a countdown clock that was set in motion the moment the fuel was created, a clock that ticks with the unhurried rhythm of nuclear physics. You can think of it like a slowly cooling cup of tea. It doesn't instantly become cold. Instead, it gradually loses its warmth to the surrounding air, its temperature dropping in a smooth, gentle curve. The power output of the Voyager probes is following a similar curve, a long, slow descent into silence. Each year, the power available to the spacecraft decreases by a small, known amount, about 4 watts. This may seem insignificant, but over the course of decades, it adds up. The 470 watts available at launch in 1977 has diminished considerably over the years. Today, the probes operate on less than half of their original power. This steady decline is the central challenge of the Voyager interstellar mission. The engineers and scientists who manage the mission are in a constant, delicate dance with this law of half-life. They are working with a power budget that shrinks a little bit more every single day. This predictability is, in its own way, very calming. There is no drama, no sudden emergency. The fate of the Voyagers is not a mystery to be solved, but a known quantity to be managed with grace and care. The half-life of plutonium-238 is a universal constant, as reliable as the force of gravity. It is a law written into the fabric of the cosmos, and the Voyager probes are simply living out their lives in accordance with it. This ever-slowing heartbeat, the gentle fading of their internal warmth, is a natural and peaceful process. It is the spacecraft's own form of aging, a slow return to the cold and quiet of the universe from which its atoms were first born. And understanding this gentle, predictable decline allows us to appreciate the careful choices that have been made to keep these messengers speaking for as long as possible. Knowing that their power source is slowly and predictably fading, the mission controllers for the Voyager probes have spent decades acting as careful, thoughtful stewards of a dwindling resource. Their work is a quiet and patient story of conservation, of making difficult choices to prolong the lives of these distant explorers for as long as humanly possible. From the very beginning, the mission was designed with this long-term power decline in mind. But as the years turned into decades, and the probes continued to function far beyond their original expectations, power management became an increasingly critical and delicate art. The process is much like managing a household budget when your income is slowly decreasing. You begin by turning off the things you don't absolutely need. In the case of the Voyager probes, this meant shutting down certain non-essential systems and heaters. In the extreme cold of deep space, many of the spacecraft's instruments require heaters to keep them at their operational temperatures. As power became more scarce, engineers had to make calculated decisions, shutting off the heaters for instruments that could tolerate the cold, or for those that were no longer the highest priority. Each time a heater was turned off, a few more precious watts were saved, extending the overall life of the mission. As the power budget continued to shrink, more difficult decisions had to be made. Eventually, the team had to begin shutting down the scientific instruments themselves, one by one. This process was done with great care, prioritizing the instruments that were most crucial for the interstellar mission. The imaging cameras which gave us the breathtaking photos of Jupiter, Saturn, Uranus, and Neptune were turned off long ago, back in 1990, as they require too much power and, in the featureless darkness between the stars, there is little for them to see. In more recent years, other instruments have been sequentially powered down. The team carefully analyzes which instruments will provide the most valuable data about the interstellar medium: the cosmic ray detector, the magnetometer, the plasma wave instrument. And they keep these running for as long as they can. Recently, the engineering team devised a clever new strategy to eke out a little more life. They realized that a safety mechanism on the spacecraft, a voltage regulator designed to protect the instruments from power surges, had a small amount of power set aside in reserve. They found a way to tap into this reserve power, using it not for emergencies, but to keep the science instruments operating for just a little longer. It was a brilliant move that is expected to postpone the shutdown of the next instrument until the year 2026. This careful, methodical, and ingenious management of a fading power supply is a testament to the dedication of the Voyager team. It is a quiet, behind-the-scenes effort, a gentle act of stewardship that has allowed these half-century-old machines to continue their historic journey. It is a story not of grand gestures, but of small, thoughtful adjustments made over many years, all to keep a faint voice from falling silent. With our understanding of the slow decline of power and the careful stewardship of the mission team, we can now look ahead to a moment that is both inevitable and deeply poignant: the time when the Voyager probes will finally fall silent. While the engineers have done a remarkable job of extending their lives, the unwavering law of half-life cannot be defied forever. A day is coming when the last scientific instrument will be turned off, and soon after, the radio transmitter itself will no longer have enough power to send a signal back to Earth. Based on the current rate of power decay, it is predicted that the final instruments will be shut down around the year 2025 to 2030. Let us take a moment to contemplate this future event. It will not be a sudden catastrophic failure. There will be no explosion, no final dramatic burst of data. Instead, It will be a quiet and graceful fading away. One day, the faint carrier signal that the deep space network has been tracking for more than half a century will simply not be there anymore. A conversation that has spanned generations of scientists and engineers will come to a peaceful end. The silence that follows will be profound. For the first time since 1977, humanity will no longer be in contact with its farthest creations. The two small voices that have been whispering back to us from the edge of the interstellar sea will be gone. This moment will mark the end of the Voyager mission as an active endeavor. The data stream will cease, and the probes will transition from being active explorers to silent, drifting artifacts. Yet, it is important to understand that this is not the end of their journey. It is only the end of our ability to listen to it. The probes themselves will continue on, their physical voyage completely unaffected by the loss of power. They are moving through the near-frictionless vacuum of space, and their momentum will carry them forward for eons. They will become, in essence, ghost ships, sailing on an endless ocean without a crew or a voice. The thought of this approaching silence can evoke a sense of melancholy, like saying goodbye to a dear, old friend. These probes have been a part of our collective consciousness for so long, a constant reminder of our ability to reach beyond ourselves. But we can also view this transition with a sense of peace and fulfillment. The Voyagers have accomplished far more than they were ever designed to do. They have given us a new perspective on our solar system, and have taken our first tentative steps into the galaxy. Their silence will be a well-earned rest. It will be the natural and expected end to a long and successful life of discovery. When that day comes, we will be left with the legacy of their data, decades of priceless information that scientists will continue to study for many years, and we will be left with the story of their journey, a story that, as we will soon explore, is only just beginning. The moment the last signal fades, and the great antennas on Earth can no longer hear the faint whisper from the Voyagers, a new chapter of their existence begins. It is the chapter of the long, silent journey. It is crucial, as we guide our thoughts towards sleep, to rest in the understanding that the end of communication is not the end of motion. The Voyagers were not propelled by rockets for their journey through the outer solar system, and they certainly are not now. Their immense speed was gained from their powerful launch and then, more significantly, from the clever use of gravity-assist maneuvers, or slingshot flybys of the giant planets like Jupiter and Saturn. Each flyby acted like a gravitational hand, flinging the probes onward at an even greater velocity. Voyager 1 received its final gravitational boost from Saturn in 1980, which sent it hurtling up and out of the plane of the planets. Voyager 2 continued on to Uranus and Neptune, receiving its own final push in 1989. Since those last encounters, the probes have been in a state of free flight, coasting on the momentum they gathered decades ago. They are like stones that have been thrown with incredible force, and in the near-perfect vacuum of interstellar space, there is almost nothing to slow them down. They are governed now by Newton's first law of motion. An object in motion stays in motion. And so, when their power finally fades completely, they will not stop. They will not slow down in any meaningful way. They will continue to sail onward, at their incredible speed of tens of thousands of miles per hour, through the darkness. This transition from an active probe to a silent artifact is a peaceful and natural one. They will become true time capsules, no longer observing their environment, but simply enduring it. Their purpose will shift from scientific discovery to simply existing, to carrying their message in a bottle, the golden record on its long, unguided journey through the Milky Way. This thought allows us to let go of the mission's end with a sense of calm continuity. The human part of the story, the part involving communication and control, will be over. But the cosmic part of the story, the physical journey of the objects themselves, will continue for a span of time that is almost beyond our ability to imagine. As we prepare to follow them on this silent voyage, let this idea settle in your mind. The end of their voice is the beginning of their true legacy as celestial wanderers. They will be like ships whose sails have been set, whose course is fixed, and who now travel at the mercy of the great slow currents of the galaxy. They are now, and will be for eons to come, humanity's most enduring physical presence in the cosmos. a silent testament to the moment in history when we first reached for the stars. And so, with their voices quieted, we can now turn our attention to the vast and silent ocean they are crossing. With the Voyagers now sailing on in silence, we can fully immerse ourselves in their new environment. Let us gently explore the nature of this interstellar ocean, the vast and empty space between the stars that will be their home for untold ages. Having passed beyond the heliopause, the quiet shore where the sun's influence fades, the Voyagers are now truly immersed in the interstellar medium. This is the material that fills the space between the star systems in our Milky Way galaxy. It is, by any earthly standard, an astonishingly complete vacuum, but it is not perfect emptiness. If you were to take a sample of this space, a volume the size of a small box, you would likely find only a single atom inside. On Earth, that same box would contain trillions upon trillions of air molecules. This profound emptiness is the defining characteristic of the Voyager's new home. The interstellar medium is composed primarily of the most basic elements in the universe: hydrogen and helium gas, remnants from the Big Bang. There are also trace amounts of heavier elements, forged in the hearts of long-dead stars and scattered into space by ancient supernova explosions. This material is not uniform. It exists in different states, sometimes as cold, neutral atoms, and sometimes as the hot, electrically charged plasma that the Voyager's instruments were able to hear. It is incredibly tenuous, a mist so fine that it is almost nothing at all. For the Voyager probes, traveling through this medium is like a ship sailing through the lightest, most ethereal fog imaginable. It offers virtually no resistance, no friction to slow their passage. This is why their momentum can carry them onward for millions of years without diminishing. The temperature of this thin gas is extreme, hovering just a few degrees above absolute zero, the ultimate cold. The probes themselves, with their internal heat source long dead, will eventually cool to this ambient temperature. Their metallic structures will become incredibly brittle, but in the absence of any force to disturb them, they will remain perfectly preserved. In this state of deep freeze, the slow march of chemical decay and corrosion that we are so familiar with on Earth simply stops. The probes will be frozen in time, protected from rust and decay by the profound cold. The environment is one of supreme preservation, a cosmic museum where artifacts can endure for eons. As the Voyagers drift through this cold and empty ocean, they have truly left the last vestiges of our solar system's environment behind. The warm breath of the solar wind is gone, replaced by the thin, ancient and incredibly cold medium of the galaxy itself. This is the sea they will now navigate for thousands, and perhaps millions, of years, a realm of profound quiet and stillness, where change happens on timescales that dwarf a human life. While the interstellar medium is incredibly sparse and cold, it is not entirely calm. It is crisscrossed by a constant, invisible rain of high-energy particles known as cosmic rays. Now that the Voyagers have traveled beyond the protective bubble of the heliosphere, they are fully exposed to this galactic radiation for the first time. The heliosphere, as it turns out, acts as a magnetic shield, deflecting a significant portion of these cosmic rays away from our solar system. This is one of the reasons why the space within our solar system is a relatively sheltered place. But out in the interstellar ocean, the Voyagers must face the full, unfiltered flux of this cosmic weather. What are cosmic rays? They are the nuclei of atoms, protons, helium nuclei, and even heavier elements that have been accelerated to nearly the speed of light. Scientists believe that many of them are born in the titanic explosions of supernovae, the death throes of massive stars. These explosions are so powerful that they can fling stellar material out into the galaxy at incredible speeds, creating a constant shower of energetic particles that permeates the entire Milky Way. One of the most important discoveries made by the Voyager probes upon entering interstellar space was the measurement of this cosmic ray environment. As soon as they crossed the heliopause, their instruments detected a dramatic and sudden increase in the intensity of this radiation, confirming that the heliosphere had indeed been shielding them. For the silent, drifting probes, these cosmic rays are a gentle but persistent force of erosion. Over very long periods of time, these tiny, fast-moving particles will act like a form of cosmic sandblasting. Each impact of a cosmic ray particle on the surface of the spacecraft can knock away a single atom. It is a process of unimaginably slow wear and tear. Over thousands or even hundreds of thousands of years, this effect will be negligible. But over millions and billions of years, this slow, steady rain of particles will gradually erode the surfaces of the probes. They will be softly worn down, their sharp edges rounded, their surfaces pitted and scarred by countless microscopic impacts. It is a quiet, patient form of decay, the universe's own slow method of breaking things down and returning them to their constituent atoms. This process poses no immediate threat to the structural integrity of the spacecraft, but it is one of the forces that will, on the longest of timescales, contribute to their eventual peaceful disintegration. For now, we can imagine them sailing through this invisible shower, enduring the faint whispers of distant, long-dead stars. In the silent darkness of interstellar space, with their own propulsion systems long silent and the push of the solar wind now just a distant memory. What guides the Voyager probes on their journey? The answer is the most fundamental and patient force in the cosmos: gravity. Having escaped the primary pull of our own sun, the Voyagers are now subject to a much larger and more subtle influence, the collective gravitational pull of the entire Milky Way galaxy. Just as the Earth is held in a steady orbit around the sun itself, along with all the other hundreds of billions of stars in our galaxy, is held in a vast, slow orbit around the galactic center. Our solar system is currently traveling at a speed of about 500,000 miles per hour on its long journey around the Milky Way. The Voyager probes, having been launched from our solar system, share this galactic velocity. Their own speed, relative to the sun, is very small in comparison. So, you can think of the Voyagers as swimmers who have pushed off from the side of a great, slowly moving ship. Their own motion away from the ship is their interstellar journey, but they are still fundamentally carried along by the ship's much larger motion through the sea. They are now free-floating objects in the galaxy, and their paths are dictated by the grand, overarching gravitational field of the Milky Way. This gravitational field is not simple, like the pull of a single star. It is the combined pull of billions of stars, vast clouds of gas and dust, and the mysterious, invisible substance known as dark matter. The Voyagers are now sailing on the gentle, invisible currents of this galactic gravity. Their paths are no longer simple straight lines, but long, graceful, curving trajectories that will see them orbiting the center of our galaxy over a period of hundreds of millions of years. Their journey is not a simple departure, but an entry into a new and much grander orbital dance. Furthermore, as they travel, they will be subtly influenced by the gravity of the objects they pass. In the far future, as we will explore, they will have distant encounters with other stars. Each of these encounters, even from light years away, will impart a tiny gravitational nudge, a gentle course correction that will slightly alter their path. Over millions of years, these cumulative nudges will weave their trajectories into a complex and unpredictable pattern. They are like cosmic driftwood, their ultimate destination unknown, their path shaped by the faint, persistent whispers of gravity from all around them. For now, they are set on a course, a long, slow arc through our local sector of the galaxy, carried onward not by any internal power, but by the silent, patient, and inescapable embrace of the galaxy's gravity. Beyond the gentle whispers of cosmic rays, there is another physical presence in the interstellar ocean: dust. The same supernova explosions and dying stars that create the elements of the interstellar gas also produce tiny, solid grains of material, microscopic particles of silicate, carbon, and ice. This interstellar dust is incredibly sparse, even more so than the gas. On average, you might find only a few dozen of these tiny grains in a space the size of a large cathedral. And yet, as the Voyager probes travel at such high speeds, even these minuscule particles can have an effect over very long timescales. Each impact from a grain of interstellar dust, though tiny, is a hypervelocity collision. It creates a microscopic crater on the surface of the spacecraft, kicking up a tiny puff of material. It is another form of slow, patient erosion, similar to the effect of cosmic rays but slightly more physical. It's like a form of cosmic weather, a very light, almost imperceptible drizzle of tiny particles that the probes must sail through for millennia. However, it is important to hold a sense of calm perspective about this. The chances of the Voyager probes colliding with anything substantial are infinitesimally small. Space is defined by its emptiness. The average distance between even small, pebble-sized objects in the galaxy is immense. The idea of the probes navigating a dense, dangerous field of asteroids or comets is a fiction of storytelling. The reality is far more serene and empty. The probes are sailing through a space so vast and so sparsely populated that a catastrophic collision is statistically almost impossible. They will be struck by countless microscopic dust grains over millions of years, and this will contribute to their slow, surface-level erosion. But the probability of them hitting an object large enough to cause significant damage, even an object the size of a grain of sand, is incredibly low. Their structural integrity is almost certainly assured for a period of time that stretches into the billions of years. So, we can release any image of a perilous journey fraught with danger. The Voyager's dance with the interstellar dust is a slow, gentle, and almost entirely harmless one. It is a quiet interaction with the oldest materials in the galaxy, the recycled remnants of ancient stars, as the probes drift silently and safely through the vast, peaceful emptiness of the interstellar ocean. Let us now bring these environmental factors together to form a complete, serene picture of the Voyager probes as they exist today, and as they will exist for eons to come. We have seen that they are sailing in a profound vacuum, a near-perfect emptiness filled with a sparse mist of ancient gas and dust. We know that they are bathed in the deep, abiding cold of interstellar space, just a few degrees from the absolute absence of heat, a temperature that preserves them from the decay we know on Earth. They are subject to a steady, gentle rain of high-energy cosmic rays and microscopic dust particles, which together create a form of cosmic weathering that erodes their surfaces on timescales of millions of years. And their path is guided not by their own power, but by the grand, silent, and inescapable currents of galactic gravity. What emerges from this is a picture of remarkable peace and stability. The interstellar ocean is not a violent or chaotic place. It is a realm of immense calm. The probes are not in danger. They are, in fact, safer and more stable in this environment than they would be anywhere in our own solar system, where the risk of collision with asteroids or comets, though still small, is significantly higher. They have reached a place of profound stillness. We can imagine them now, these silent, ghost-like ships drifting through the dark, their golden records, carrying the sights and sounds of our world, are safely shielded beneath their covers. Their antennas, which once looked back toward Earth, now point uselessly into the void. Their instruments are cold and silent, their power long since faded. They have become passive observers, or rather passive participants in the slow life of the galaxy. They are artifacts, pure and simple, relics of a distant time and a far-off civilization. They are like ancient ships discovered at the bottom of the deepest ocean, perfectly preserved by the cold and the dark. But these ships are not at rest. They are on a continuous, unending voyage. They are vessels in a state of vast calm, subject only to the most gentle and patient of cosmic forces. This state of serene endurance is their new reality. And as we hold this peaceful image in our minds, of these two small, silent ships sailing on a perfectly calm and endless sea, we can prepare to look much further into their future, to their first gentle encounters in this new and boundless ocean. Having settled into the calm reality of the interstellar cruise, we now take our first great leap forward in time. We journey with the silent probes for thousands of years, to the very edge of our own solar system, a vast and mysterious region known as the Oort cloud. As the Voyager probes continue their silent journey outward, they are still, for a very long time, technically within the gravitational influence of our Sun. That influence extends to a mind-boggling distance, encompassing a vast spherical region of space filled with icy bodies. This is the Oort cloud, the final and most distant frontier of our solar system. The journey to even the inner edge of this cloud is not a short one. The probes, despite traveling at over 35,000 miles per hour, will take about 300 years just to reach the beginning of this region. And the cloud itself is so immensely vast that it will take them tens of thousands of years to cross it. Let us pause to feel the weight of this timescale. 300 years is a span of time that takes us back to the early 18th century on Earth, and that is just the beginning of the journey. To cross the Oort cloud will take an estimated 30,000 years. 30,000 years ago, our own ancestors were living in the Stone Age, painting images on cave walls. This is the kind of deep, patient time we must embrace to follow the Voyagers on their path. During this long passage, the probes will be cold, silent, and unobserved. Humanity may have changed in ways we cannot imagine, or we may not be here at all. But the Voyagers, governed by the simple laws of motion, will continue their steady, unwavering flight. This journey to and through the Oort cloud is a quiet, uneventful one. It is a period of pure transit, a long, dark cruise through the outermost suburbs of our solar system. The probes will be too far for any signal to ever reach us. Their power sources having been exhausted for millennia, they will be simple, inert objects, coasting on their ancient momentum. Thinking about this timescale helps to dissolve our own sense of urgency. The universe operates on a schedule that is profoundly slow and patient. The journey of the Voyagers has now become a part of that cosmic rhythm. As we relax and let our thoughts drift, we can release our attachment to the fast pace of our own lives and settle into the slow, deep, and peaceful timescale of this 30,000-year passage through the great and distant cloud. It is a journey of serene, uninterrupted flight, a long and quiet preamble to their true departure from our sun's family. So, what is this mysterious region that takes 30,000 years to cross? The Oort cloud is not something we have ever seen directly. It is too far away, and its objects are too small and dark to be imaged by our telescopes. Its existence is a beautiful piece of scientific inference, a conclusion drawn from observing the celestial visitors that sometimes grace our skies. Long-period comets. These are the comets that come from the deepest reaches of the solar system, with orbital periods lasting thousands or even millions of years. By studying their trajectories, astronomers in the mid-20th century, most notably Jan Oort, deduced that they must originate from a vast, spherical reservoir of icy bodies surrounding our entire solar system. This theoretical reservoir is what we now call the Oort cloud. Imagine our solar system with the Sun and the planets as a small, compact city center. The Kuiper Belt, home to Pluto and other icy worlds, is like the first ring of suburbs. The Oort cloud, then, is like a vast, sparsely populated rural countryside that extends for an immense distance in every direction. It is thought to begin at a distance of a few thousand times the space between the Earth and the Sun, and it may extend out to a light year or more, perhaps halfway to the nearest star. It is a sphere of unimaginable size, and our planetary system is just a tiny speck at its very center. The Oort cloud is believed to be a remnant of the very formation of the solar system, some 4.5 billion years ago. It is composed of trillions of icy planetesimals, small bodies made of frozen water, methane, ammonia, and other compounds. These are the primordial building blocks of the planets that were never incorporated into larger worlds. In the early chaotic days of the solar system, the gravitational pull of the giant planets, particularly Jupiter, would have flung these icy bodies out into these distant, stable orbits, creating the vast spherical cloud we theorize today. The objects in the Oort cloud are held only very loosely by the Sun's gravity. They are so far away that the gravitational pull of passing stars, or even the tidal forces of the Milky Way galaxy itself, can sometimes disturb their orbits. Every now and then, one of these icy bodies is nudged out of its stable path and begins a long, slow fall toward the inner solar system. As it gets closer to the Sun, its ice begins to warm and turn to gas, creating the beautiful tail that we recognize as a comet. Every long-period comet that we see is a visitor from this distant, invisible realm, a messenger from the Oort cloud giving us a clue about the vastness of our own solar system. This is the region the Voyagers are destined to cross, not a crowded field, but a serene and mostly empty sphere of ancient, frozen worlds. When we hear the word cloud, we might imagine something dense and opaque, like the clouds in our sky or the swirling gas of a nebula. And when we think of a region filled with trillions of comets, we might picture a chaotic, crowded space, a dangerous cosmic minefield for any spacecraft to navigate. But the reality of the Oort cloud is one of profound, almost perfect emptiness. This is a crucial point to hold in our minds for a sense of peace and calm. The passage of the Voyager probes through this region will be an extraordinarily safe and uneventful one. The reason for this lies in the sheer scale of the Oort cloud. While it may contain trillions of objects, the volume of space it occupies is so staggeringly immense that the average distance between any two of these icy bodies is millions of miles. To try and visualize this, imagine a single grain of sand. Now, imagine another grain of sand several miles away, and then another several miles from that one. That is a more accurate representation of the density of the Oort cloud. It is a cloud in the astronomical sense, meaning a vast collection of objects that are gravitationally associated. But it is not a cloud in the visual sense. For all practical purposes, it is empty space. The chances of either Voyager probe colliding with an object in the Oort cloud, even an object the size of a pebble, are astronomically small, so close to zero as to be considered impossible. They will drift through this vast sphere for 30,000 years, and will almost certainly never come close enough to one of its icy residents to even detect it. They will not be dodging comets or navigating a treacherous field of debris. Their journey will be a smooth, straight, and uninterrupted passage through a silent and empty realm. This understanding replaces any feeling of peril with one of serene solitude. The Oort cloud is not a barrier or a danger to the Voyagers. It is simply a vast, quiet space they must cross on their journey outward. It is the final, extended farewell from our solar system, a 30,000-year-long slow fade-out. As they travel through this region, they will be utterly alone, just as they were in the interstellar space before it, and just as they will be in the interstellar space after it. The journey remains one of immense calm and predictability. And so, we can rest easy, knowing that our silent messengers will pass through this final frontier of our solar system safely, their long voyage undisturbed by the ancient, frozen worlds that wander so very far apart in the deep, cold dark. Let us rest for a moment longer with the timescale of this passage. We have established that it will take about 300 years to reach the inner edge of the Oort cloud, and that the cloud itself may take as many as 30,000 years to traverse. For a significant portion of this time, for perhaps the first 20,000 years of this crossing, the Voyager probes will still be technically bound by the sun's gravity. They will be in a region where the sun is still the dominant gravitational influence, even if that influence is incredibly weak and tenuous. They are still, in a very real sense, part of our solar system's family, albeit the most distant and estranged members. This immense duration, this 20,000-year period of being almost free, reinforces the almost unimaginable scale of our solar system when defined in its entirety. We are used to thinking of the solar system as ending with the orbit of Neptune or the Kuiper belt. But gravitationally, its reach is 1,000 times greater. The Voyagers must cross this vast, extended sphere of influence before they can truly be considered interstellar objects in the gravitational sense. This period of crossing is a kind of cosmic limbo. The probes will have left the planetary region long ago. They will have been silent for millennia. They will be deep within the cold, dark environment of the Oort cloud. And yet, they will still be tracing a path that is ultimately tied to the star they left so long ago. This long, slow process of departure brings a sense of peaceful finality. There is no abrupt exit from our solar system. Instead, it is a gradual release, a slow and patient letting go that takes longer than all of recorded human history. It is a transition so slow that it becomes a state of being in itself. For 20,000 years, the probes will exist in this in-between state, a testament to the vastness of the sun's quiet, gravitational reach. As we let our minds drift, we can feel the deep peace in this slow, unhurried departure. There is no rush. The cosmos is patient, and the Voyagers have now fully adopted its gentle, unhurried pace. After 30,000 years of silent flight through the vast, empty spaces of the Oort cloud, the Voyager probes will cross another invisible, yet deeply significant, boundary. They will pass beyond the outer edge of the cloud, into a region of space where the sun's gravitational pull is no longer the dominant force. At this immense distance, perhaps a light year or more from home, the faint gravitational tug of the nearest stars, and the overall tidal pull of the Milky Way galaxy, will finally become stronger than the pull of the sun. This moment marks their true departure from our solar system. They will no longer be members of the sun's family. They will become free and independent citizens of the galaxy. This is a profound transition, though one that will happen with no ceremony at all. The silent, frozen probes will feel no change. Their trajectory, which has been a long, slow escape from the sun's gravity, will now begin to be shaped more by the gravity of other, distant stars. They will have finally and truly entered the interstellar ocean, not just in terms of the medium they are traveling through, but in terms of the forces that guide their path. We can think of it as a boat that has been drifting down a long, slow river, the sun's gravitational well. For its entire journey, the river's current has been the primary force dictating its motion. But now, the boat has reached the mouth of the river and has drifted out into the open sea. The faint current of the river is gone, and the boat is now moved by the great, slow tides and currents of the ocean itself. This moment of departure, some 30,000 years in our future, is the true beginning of their endless wandering journey. Up until this point, their path has been, in a broad sense, predictable, a straight line away from their origin. But now their future trajectory becomes a beautiful unknown. It will be a long, meandering path woven by the gentle, cumulative gravitational nudges of countless passing stars over millions and billions of years. They will be like cosmic seeds, cast from their parent plant, now drifting on the galactic winds, their ultimate destination entirely unplanned and unknown. And as they leave the sun's family behind forever, they are already on a path that will, after another 10,000 years, bring them to their very first close encounter with another star. Having finally and truly departed our solar system, the Voyagers are now free-drifting citizens of the galaxy. We now leap forward another 10,000 years to witness their first greeting, a slow, distant and silent passage by a neighboring star. In about 40,000 years from now, after a long and lonely journey through the dark, Voyager 1 will have its first close encounter with another star. This star is known as Gliese 445, a faint red dwarf star located in the constellation Camelopardalis. To be clear, Voyager 1 is not aimed at this star. Its current trajectory is simply a result of the gravitational slingshot it received from Saturn back in 1980. It is purely by cosmic coincidence that this trajectory will, in the distant future, carry it relatively close to this particular star. At the same time, the star Gliese 445 is also moving through the galaxy, and its own path is bringing it closer to our solar system. So, this future encounter is a chance meeting, a moment when two independent paths through the galaxy happen to intersect in time and space. Let us once again settle into the timescale. 40,000 years. This is a span of time that is difficult for the human mind to hold. It is a period longer than all of civilization, longer than the time since our ancestors painted the first art on cave walls. Throughout this immense passage of time, Voyager 1 will continue its silent, unpowered flight. It will be a cold, inert relic, its mission a forgotten memory from the distant past. It will travel through the vast, empty darkness, its journey marked only by the slow, patient ticking of the cosmic clock. This long wait is a testament to the sheer emptiness of our galactic neighborhood. Even though there are billions of stars in the Milky Way, the average distance between them is immense. It takes tens of thousands of years, even traveling at more than 35,000 miles per hour, to travel from one star system to another. So, this first encounter is a major milestone in the very long life of the Voyager probe. After 40,000 years of solitude, it will finally pass through the sphere of influence, however weak, of another sun. It is a quiet, patient rendezvous in the deep future, a moment that will be the first of many such encounters as the probe continues its endless wandering through the starfields of the Milky Way. Having established the 40,000-year timescale for this encounter with the star Gliese 445, it is important to gently clarify what astronomers mean by a close encounter in this context. The words can conjure images of the probe flying through a new solar system, weaving past alien planets. But the reality is far more vast, distant, and serene. When Voyager 1 makes its closest approach to Gliese 445, it will pass by at a distance of about 1.6 light-years. Let us pause to feel the scale of that distance. A single light-year is the distance light travels in a year, a measure of almost 6 trillion miles. So Voyager 1 will miss the star by nearly 10 trillion miles. To put that in perspective, the closest star to our own Sun, Proxima Centauri, is about 4.2 light-years away. So, Voyager 1's close pass will still be more than a third of the distance from our Sun to its nearest neighbor. From the vantage point of the silent probe, the star Gliese 445 would appear as a bright reddish star in the sky. It would be significantly brighter than it appears from Earth, as the probe will be much closer, but it would still be just a point of light. There would be no visible disk, no sense of approaching a sun. There is absolutely no danger of the probe colliding with the star or any potential planets that might be orbiting it. The encounter is close only by the immense standards of interstellar travel. It is significant not because of any immediate drama, but because it is the first time that the probe's trajectory will be measurably influenced by the gravity of another star. It is a gentle, gravitational handshake across a vast and empty gulf of space. We must release any notion of a perilous or exciting flyby. The encounter will be slow, silent, and stately. The probe will spend thousands of years approaching the point of closest passage and thousands of years receding from it. It is a long, graceful curve in its path, not a sharp turn. This understanding allows us to view the event with a sense of calm and peace. It is not a dramatic event, but a subtle and gentle interaction, a quiet greeting in the dark between a tiny ancient artifact from Earth and a lonely, wandering star. Though the passage of Voyager, won by the star Gliese 445, will occur at the immense distance of 1.6 light-years, the encounter will not be without consequence. The force of gravity, while it weakens with distance, is infinite in its reach. Every object in the universe exerts a gravitational pull on every other object. And so, as the probe passes by, the gravity of the distant red dwarf star will gently but inexorably pull on it. This pull will be incredibly faint, a whisper of a force compared to the pull of our own Sun that the probe has spent its life escaping. But in the quiet stillness of interstellar space, even the faintest of forces, applied over a long period of time, can have a noticeable effect. This gravitational interaction will be a slow, graceful dance. For thousands of years, as Voyager 1 approaches the star's gravity will gently pull it forward, slightly accelerating it along its path. As it reaches the point of closest approach and then begins to recede, the star's gravity will pull it back, slightly slowing it down. But because the probe is not passing by in a perfectly straight line relative to the star, the overall effect will be a slight bending of its trajectory. It will receive a gentle gravitational nudge, a quiet and subtle course correction. The probe's direction of travel will be altered by a very small, almost imperceptible amount. Its speed may also be slightly changed, either increased or decreased, depending on the precise geometry of the encounter. This is the same principle as the gravity assist maneuvers the probe used to navigate the outer solar system, but on a much grander and more subtle scale. There, it used the powerful gravity of giant planets to fling itself onward. Here, it is interacting with the faint gravity of a distant star. The effect is not dramatic. It will not be thrown into a new orbit or sent careening off in a wild new direction, but it is significant. It is the first time another star will have a say in the probe's destiny. After this encounter, Voyager 1 will be set on a new path, a new long straight line through the galaxy until, tens or hundreds of thousands of years later, it has another distant encounter with another star, and its path is nudged once again. The probe's long-term journey through the Milky Way will be a sort of cosmic pinball game, played on an immense scale with incredibly gentle flippers. Each stellar encounter will be a small deflection, And over millions of years, these tiny nudges will accumulate, causing the probe to wander on a complex, unpredictable path. This first nudge from Gliese 445 is the beginning of that process. It is the moment the probe's fate is no longer solely determined by its past, but begins to be shaped by its new interstellar neighbors. It is a quiet, peaceful, and deeply significant moment in its endless silent voyage. Let us pause now to contemplate the profound solitude of this future event. The close pass of Voyager, won by the star Gliese 445 some 40,000 years from now, will occur in complete and utter isolation. There will be no one there to witness it. The probe itself, of course, will be a cold, dead, and unseeing object. Its cameras, its sensors, its radio, all will have been silent for millennia. It will be completely unaware of the milestone it is achieving, oblivious to the fact that it is making its first greeting to another solar system. It is a visitor that cannot see, and from the perspective of any potential worlds orbiting that distant star, the encounter will be equally invisible. The Voyager probe is a tiny object, only a few meters across, and it will be trillions of miles away. It reflects no light to speak of, and emits no heat or radiation. It will be a speck of matter so small and so dark that it would be utterly impossible to detect with any conceivable technology. It is a visitor that cannot be seen. This encounter, this first handshake between an artifact of humanity and another star, will happen in the deepest and most profound silence, unobserved and unrecorded by anyone. This thought brings a deep sense of peace and humility. So much of our human endeavor is tied to observation, to recording, to being seen. We launch missions to see new worlds. We build telescopes to be our eyes on the cosmos. But the longest and perhaps most significant part of the Voyager journey will be entirely unwitnessed. Its story will unfold in the dark, a private history written only in the subtle changes of its own trajectory. This removes any sense of performance or drama from the event. It is a pure, natural, cosmic interaction, as simple and as unself-conscious as a stone rolling down a hill. It is a quiet reminder that the universe does not need an audience to continue its slow and patient dance. And as we rest here, we can find a serene comfort in that thought, in the knowledge that our small messenger will continue its journey. Its milestones passed in a quiet, dignified, and beautiful anonymity. The gentle, distant flyby of Gliese 445 is not an ending but a beginning. It is the first of what will be a long, long series of similar encounters in the deep future of the Voyager probes. As they continue their journeys through the Milky Way, their paths will, by chance, carry them into the general vicinity of many other stars. Voyager 2, for instance, is on a path that will bring it within a few light-years of the star Ross 248 in about the same time frame, around 40,000 years from now. And after that, in the truly distant future, about 296,000 years from now, it will pass about 4 light-years from Sirius, the brightest star in our night sky. These encounters are the predictable milestones we can calculate for now. But over millions and billions of years, the probes will have countless such distant flybys. The galaxy is a dynamic place. Stars are not fixed points of light. They are all in constant motion, orbiting the galactic center, each on its own unique path. The future history of the Voyager probes will be a long and meandering one, their paths woven by the cumulative gravitational nudges of all the stars they pass. Some encounters will be closer, some farther. Some will slightly speed the probes up, others will slow them down. Some will bend their paths in one direction, others will bend them in another. Over immense timescales, their trajectories are therefore chaotic and unknowable. We can predict the next few flybys, but we cannot know where the probes will be in 1 billion years. They will become true galactic wanderers, their ultimate fate tied to the chance encounters they have along the way. This long future of stellar encounters sets the stage for the next part of our quiet contemplation. If the probes are to wander for millions or even billions of years, we must ask, can they physically survive for that long? What are the slow, patient forces that might eventually lead to their decay? This question invites us to look at the very materials the probes are made of, and to consider their endurance in the face of the most patient force of all, time itself. The journey now takes us into the realm of deep time, into a future measured not in thousands but in millions of years. If the Voyagers are to sail the interstellar ocean for so long, we must gently consider the forces that will test their endurance, the slow and patient processes that will eventually lead to their unraveling. As the Voyager probes drift through the galaxy for millions of years, they will be subject to the slow, relentless process of cosmic weathering. We have already touched upon the two main agents of this process: the constant rain of high-energy cosmic rays, and the occasional impact of microscopic interstellar dust grains. On the timescale of a human life, or even the entire history of civilization, the effects of this erosion are practically zero. But when we extend our view to 1,000,000 years, or 10 million, or 100 million, these incredibly slow processes begin to add up, and their cumulative effect becomes significant. Let us first consider the cosmic rays. These are mostly protons and other atomic nuclei, stripped of their electrons and accelerated to near light speed. Each one is like a tiny, invisible bullet. When a cosmic ray particle strikes the surface of the Voyager spacecraft, it imparts a small amount of energy. Most of the time, this energy simply heats the surface by a tiny, insignificant amount. But every now and then, a particle will strike with enough force to kick an individual atom completely off the surface of the spacecraft. This process is called sputtering. It is an atomic-scale sandblasting, a gentle but ceaseless wearing away of the probe's outer layers. Then there is the interstellar dust. These are tiny grains of silicate and carbon, typically smaller than the particles in smoke. Though they are incredibly sparse, the Voyager probes are sweeping through space at such high velocity that even these small impacts occur with a great deal of energy. Each impact creates a tiny microscopic crater, vaporizing a small amount of both the dust grain and the spacecraft's surface. Over millions of years, the surfaces of the probes will become pitted and scarred with countless trillions of these microscopic craters. Together, sputtering from cosmic rays and cratering from dust will act to slowly erode the probes. The effect will be incredibly gradual, a loss of perhaps a few millimeters of surface material over millions of years. Sharp edges will become rounded. Smooth surfaces will become rough and dull. It is the universe's own slow, patient method of polishing, of breaking down complex structures and returning them to their simpler forms. This slow erosion is one of the primary forces that will determine the ultimate lifespan of the probes as recognizable, intact objects. To make the abstract process of slow erosion more tangible, let us focus on one specific iconic part of the Voyager spacecraft: the protective cover of the Golden Record. This cover is a beautiful piece of design in its own right. Made of aluminum and electroplated with a sample of pure uranium-238, it is designed to protect the delicate grooves of the record beneath from the impacts of interstellar dust. But it also serves another purpose. Etched onto its surface is a set of simple, elegant diagrams, a kind of instruction manual for any potential finder of the record. These diagrams show the location of our Sun relative to 14 pulsars, a kind of cosmic lighthouse that can be used to pinpoint our position in space and time. They also show how to play the record, indicating the correct rotational speed, and how to use the included cartridge and needle to decode the sounds and images stored within. It is a message of pure, hopeful science, an attempt to communicate across the gulf of species and millennia. But this beautiful, hopeful message is not immune to the slow weathering of interstellar space. The same forces of erosion that will wear away the rest of the spacecraft, the constant, gentle rain of cosmic rays, and the impacts of micrometeoroids will also act upon this cover. Atom by atom, the process of sputtering will knock away the aluminum from the surface. The lines of the diagrams, which are only etched to a shallow depth, will slowly begin to fade. The sharp, clear edges of the drawings will soften and blur. Over hundreds of thousands of years, the diagrams will become less distinct. Over a few million years, they may become faint and difficult to decipher, and over tens or hundreds of millions of years, it is likely that the diagrams will be erased completely, worn away by the patient sandblasting of the cosmos. The cover itself will remain, its purpose as a shield still intact for a very long time. But the message etched upon it, the friendly invitation from humanity, will have vanished. This is a peaceful, not a tragic thought. It is a reminder of the immense timescales at play. The record was designed to last for 1 billion years or more, and the information within its grooves will likely survive far longer than the instructions on its cover. But the slow fading of these diagrams is a poignant and tangible symbol of the immense, patient power of cosmic erosion, the gentle, inevitable process by which the universe smooths away all things. Beyond the slow erosion of its surfaces, another profound environmental factor will define the Voyager's existence over millions of years: the extreme, abiding cold of deep space. Once their internal power source, the warm heart of plutonium, has fully decayed and cooled after many centuries, the probes will no longer generate any internal heat. They will slowly, over a very long time, reach thermal equilibrium with their surroundings. They will cool down to the background temperature of the interstellar medium, a mere 2.7 Kelvin, or about -455 degrees Fahrenheit. This is just a few degrees above absolute zero, the theoretical point at which all atomic motion ceases. This state of profound cold will have a significant effect on the very materials from which the probes are built, leading to a state of extreme fragility, but also of incredible preservation. In this intense cold, the properties of metals and other materials change dramatically. Most metals, including the aluminum and other alloys that make up the structure of the Voyager spacecraft, will become incredibly brittle. The atoms within their crystal lattices will be locked rigidly in place, with very little thermal energy to allow them to move or flex. This means that the materials will lose all of their ductility, their ability to bend or deform without breaking. The probes will become as fragile as glass. A small, sharp impact that might only dent the spacecraft at room temperature could, in the deep cold of space, cause a brittle fracture, shattering a component into pieces. However, this extreme fragility is paired with an equally extreme state of preservation. The cold is so intense that it effectively stops all chemical reactions. The processes of corrosion and oxidation, what we would call rust or tarnish on Earth, require a certain amount of thermal energy to proceed. In the near absolute zero temperatures of interstellar space, these reactions slow to a virtual standstill. The metals of the spacecraft will not rust. The plastics and polymers will not degrade or become discolored. The probes will be frozen in a state of suspended animation, perfectly preserved from chemical decay. They will become pristine, frozen relics. So, we have a curious duality. The Voyagers will be, at once, incredibly fragile and perfectly preserved. As long as they do not suffer a significant physical impact, their structures could remain intact and recognizable for billions of years. The cold protects them from the slow internal unraveling of chemistry, while making them vulnerable to any external force. But as we have already discussed, the chances of a significant impact in the vast emptiness of interstellar space are vanishingly small. And so, the most likely state for the probes will be one of peaceful, frozen, brittle endurance. We can picture them, sailing on through the dark, their forms unchanged for eons, gleaming silently in the starlight, preserved by the very cold that makes them so fragile. It is a state of serene, crystalline stillness, a long and quiet sleep in the heart of the cosmic winter. As we contemplate the Voyagers in their future state, cold, brittle, and silent, it is natural for our minds to wonder about the possibility of a sudden end. Could their journey be cut short by a catastrophic collision with another object? It is important to address this thought directly, and to find peace in the statistical reality of the interstellar ocean. The likelihood of either Voyager probe ever colliding with a large object is, for all practical purposes, zero. The reason for this comes back to the single most defining characteristic of space: its emptiness. We see images of dense asteroid belts in movies and television shows, but the reality, even within our own solar system's asteroid belt, is one of immense separation. The average distance between asteroids is hundreds of thousands of miles. The Voyager probes pass through our own asteroid belt without any issue, and indeed, without ever even seeing an asteroid. The interstellar medium is vastly emptier still. While there are certainly rogue planets, brown dwarfs, and other wandering objects drifting in the darkness between the stars, the volume of space is so staggeringly large that the chances of a tiny, meter-sized spacecraft randomly intersecting with one of them are infinitesimally small. Statistically, the probes could travel for billions, or even trillions, of years before a random collision with an object large enough to destroy them would be expected to occur. They are far more likely to be slowly eroded into nothingness by dust and cosmic rays, or to be gravitationally disrupted by a close pass to a star, than they are to be shattered by a sudden impact. So, we can safely and calmly release any image of a violent end for the Voyagers. Their story is not one of drama or peril. It is a story of slow, patient, and gentle processes. Their end, when it eventually comes hundreds of millions or billions of years from now, will almost certainly be as quiet and as peaceful as their long journey. For now, and for a future so long it is nearly eternal, they are safe in the vast, empty harbor of interstellar space. Bringing together these thoughts on erosion, cold, and the improbability of collision, we can now form a final, serene image of the Voyager probes as they will exist in the deep future. After millions of years, they will be ghost ships in the truest sense, ancient mariners on an endless cosmic sea. Their surfaces will be weathered and worn by the slow, gentle sandblasting of cosmic rays and interstellar dust. The sharp, clean lines they possessed at their launch will have been softened and rounded. The vibrant colors of their logos and insignia will have been bleached away by radiation. The elegant diagrams on the golden record's cover will be a faint, ghostly memory, or perhaps erased entirely. Internally, they will be frozen solid, their materials rendered as brittle as ancient glass by the profound cold of deep space. They will be utterly inert, with no power, no warmth, and no thought. And yet they will be, to a very large degree, intact. Their fundamental structure, the large circular antenna, the long boom holding the science instruments, the central bus containing their silent electronics will all still be there. They will be recognizable as objects of intelligent design, even after eons of cosmic weathering. They will be humanity's most enduring monuments, outlasting any pyramid, any cathedral, any structure ever built on the surface of the earth. The image is one of profound peace and endurance. A silent, frozen ship, sailing on an endless, calm sea, its form slowly and gently softened by the mists of time. It is a vessel carrying a message that may never be read, a testament to a species that may long since be gone. But its existence alone is a message. The very fact that such an object is drifting between the stars speaks to the curiosity and the hope of the beings who built it. As we prepare to turn our attention to the message they carry, we can hold this image in our minds. The serene, enduring, and almost eternal form of the ghost ship sailing on largely whole through the vast and quiet night. Having considered the immense journey and the physical endurance of the Voyager probes, let us now turn our attention to their heart, to the hopeful purpose with which they were sent into the void. Let us gently explore the story of the golden record. Affixed to the side of each Voyager spacecraft is a small, precious object. A phonograph record, 12 inches in diameter, its surface plated in gold. This is the golden record, and it represents the deepest and most hopeful ambition of the entire Voyager mission. It is a message in a bottle, cast into the cosmic ocean. It was conceived and assembled in the 1970s by a small committee chaired by the astronomer Carl Sagan. The team was faced with a profound and beautiful challenge. If you could send a single message to an unknown, intelligent civilization in the distant future, what would you say? How would you tell the story of our world? The purpose of the record was not to seek out communication. The chances of it ever being found are, as we have discussed, infinitesimally small. The purpose was more symbolic, more philosophical. It was an act of reaching out, an expression of our own curiosity and our hope that we are not alone in the universe. It was a way of placing a small part of ourselves, our art, our science, and our sounds, into a time capsule that could potentially outlast our planet and our species. The record is a gesture of peace and friendship, a greeting card sent to the cosmos with no return address. The medium chosen, a phonograph record, may seem quaint to us now, in our digital age, but it was, at the time, a durable and elegant way to store a great deal of information, both sound and images, in a physical form that could last for an immense amount of time. The record is made of copper, and then plated in a thin layer of gold to protect it from erosion. It is sealed in an aluminum cover, which, as we know, includes instructions on how to play it. The very act of creating such an object, of carefully selecting its contents and building it to last for 1 billion years, was an act of profound optimism. It was a declaration that our world, our lives, and our cultures were worth remembering, worth preserving, and worth sharing. It transforms the Voyager probes from simple scientific instruments into something more. They are emissaries, carrying the collective memory of a tiny, distant world on its journey into the great unknown dark. Let us now imagine placing the needle on the golden record and listening to the story it tells through sound. The audio portion of the record begins with a collection of greetings. In 55 different languages, human voices say a simple, peaceful hello. From ancient languages like Akkadian and Sumerian to modern tongues from every corner of the globe, the message is one of universal, friendly welcome. One of the greetings is from the then Secretary General of the United Nations, who speaks of our hope for peace and our wonder at the universe. This chorus of voices is the first handshake, the first offering of connection. Following the greetings is a beautiful and evocative montage called The Sounds of Earth. This 12-minute sequence is a sonic poem, designed to paint a picture of our planet for ears that have never heard it. It begins with the fundamental sounds of our world, the rumble of volcanoes, the crash of thunder, the whisper of the wind, and the gentle lapping of ocean waves. It then moves to the sounds of life, the chirping of crickets and frogs, the songs of birds, the calls of elephants and chimpanzees, and the haunting, beautiful songs of humpback whales. Finally, it introduces the sounds of humanity. We hear the crunch of footsteps, the sound of a blacksmith's hammer, the roar of a tractor, and the whistle of a train. We hear a mother's first words to her newborn child, and the sound of laughter. It is a rich and peaceful tapestry of sound, a carefully curated collection designed to convey the feeling of being alive on our vibrant, noisy planet. The largest portion of the record's audio is dedicated to music. The 90 minutes of musical selections are a journey through global culture and history. There are pieces from classical European composers like Bach and Beethoven. There is the driving rhythm of Chuck Berry's rock and roll song, Johnny B. There are traditional songs from Peru, from the Solomon Islands, from Australia, and from many other cultures around the world. The selection was not meant to be a greatest hits, but rather a representation of the diversity of human emotional expression through music. It is a collection filled with joy, with melancholy, with reverence, and with love. It is perhaps the most direct and powerful way the record attempts to communicate our shared humanity, through the universal language of music. This collection of sounds, from the wind to the whales to the works of Bach, is a peaceful and hopeful portrait of our world, a symphony of life sent out into the quiet of the cosmos. Beyond the rich tapestry of sound, the golden record also carries a treasure trove of images, a visual story of our world and its inhabitants. There are 116 photographs and diagrams encoded in an analog format onto the record. The instruction manual on the cover explains how to reconstruct these images from the audio signals. The process of selecting these few images, from the billions that could have been chosen, was a monumental task of curation, an attempt to summarize the entirety of the human experience in a small, silent slideshow. The sequence begins with the universal language of science and mathematics. There are diagrams showing our numbering system, our units of measurement, and our understanding of physics and chemistry. There is a map of our solar system, showing the trajectory of the Voyager spacecraft leaving the third planet. There are diagrams of our DNA, the blueprint of all life on Earth, and detailed anatomical drawings of the human body, explaining our biology and the process of reproduction. These first images are designed to establish a common ground, a shared understanding of the physical laws that govern the universe, before moving on to the more personal story of our world. The slideshow then blossoms into a vibrant portrait of Earth and its life. There are photographs of our planet from space, the beautiful blue marble. There are images of our geological features, deserts, mountains, rivers, and coastlines. There are pictures of snowflakes and trees, of insects and flowers, of dolphins leaping from the sea. The images then turn to humanity. We see people from many different cultures of all ages, in all walks of life. We see them eating, drinking, and playing. We see a picture of an orchestra, a runner in the Olympic Games, and an astronaut floating in space. There are images that depict our technology: houses, bridges, cars, and airports. The selection was carefully made to be as inclusive and as peaceful as possible. There are no images of war or conflict. The story the pictures tell is one of a curious, diverse, and creative species living on a beautiful and vibrant planet. Each image is a small window into our world, a single frozen moment chosen to convey a wealth of information. A photograph of a woman with a microscope tells a story about science and discovery. A picture of a family sharing a meal tells a story about community and love. Taken together, these 116 images are a silent, visual poem. They are a loving and carefully constructed portrait of who we were, in one small moment in time, offered with hope and humility to the vast and unknown future. As we reflect on the carefully chosen sounds and images on the golden record, a gentle and profound realization begins to settle in our minds. This message was not created for us. Its intended audience is entirely other, a hypothetical and unknown intelligence, perhaps millions of years in the future, long after we, its creators, are gone. This shifts our perspective on the entire endeavor. It ceases to be just a collection of our culture and becomes a true act of communication with the unknown. The team that assembled the record had to constantly imagine this other mind. They could make no assumptions about shared biology, shared culture, or shared senses. Would the finders have ears to hear the music? Would they have eyes to see the images? The entire project was an exercise in cosmic empathy, an attempt to create a message so fundamental that its meaning might shine through, even across the immense gulf of biological and cultural difference. This is why the record begins with science and mathematics, the one language that is believed to be truly universal. The hope was that any technologically advanced civilization would understand the principles of physics and astronomy, and that this could be the key to unlocking the rest of the message. This act of creating a message for an unknown other is an act of profound humility. It acknowledges our own mortality, our own impermanence. The record is a tacit admission that our civilization may not last forever, but that the things we valued, our science, our art, our love for our world, are worthy of being remembered. It is a kind of cosmic legacy, a final testament. The creators of the record will never know if their message is received. We will never know. The question will remain unanswered, perhaps forever. And in this gentle uncertainty there is a deep peace. The value of the golden record is not in its reception, but in its creation. It is a monument to the moment when a young, curious species, living on a small, fragile world, looked up at the stars and felt a deep and noble desire to say, hello. In the end, the golden record is best understood as the ultimate time capsule. A time capsule is a container of artifacts from one period of time, buried or stored with the intention that it be opened in the future. The golden record is the grandest realization of this concept ever attempted. Its intended future is not a specific date a century from now, but the deep, almost unimaginable future of the cosmos. Its intended recipient is not a future generation of humans, but an entirely unknown form of life. And its vessel is not buried in the ground, but is sailing through the stars on a journey that will last for 1 billion years. The physical record itself was built to endure. The gold-plated copper disc is a stable and robust medium. Scientists have estimated that the record, shielded by its cover, will remain playable and its data recoverable for at least 1 billion years, and perhaps longer. Over these immense timescales, it is very likely that the record will outlast not just the civilization that created it, but perhaps every single trace of humanity on Earth. The slow, patient forces of erosion, plate tectonics, and the eventual expansion of our own sun will, over hundreds of millions of years, erase every city, every monument, and every fossil from the surface of our planet. But out in the cold, stable, and empty environment of interstellar space, the Voyager probes and their precious cargo will continue to endure. They will become the last surviving relics of our existence, the sole proof that we were ever here. This thought is not a sad one, but one of awe and wonder. It is a humbling and peaceful realization of our small place in cosmic history, and of our ability to create something that can transcend our own fleeting existence. The golden record is a whisper of our story, entrusted to the patient keeping of the galaxy. It is a bet against oblivion, a hopeful gesture that says, we were here, we lived, we wondered. And as the silent probes carry this ultimate time capsule on their endless journey, they become more than just machines. They become our memory, our legacy, and our most enduring connection to the vast and timeless universe. Having explored the enduring message of the golden record, we now zoom our perspective out to the grandest possible scale. We will see that the Voyagers are not just leaving our sun, but are now engaged in a new and unimaginably long dance, a slow, patient orbit around the center of the Milky Way galaxy itself. It is a common misconception to think of the Voyager probes as simply traveling in a straight line, away from the sun, forever. While this is true from our solar system's perspective, it misses a larger, more graceful motion. The reality is that the Voyagers, having escaped the sun's primary gravitational pull, have now become independent objects orbiting the center of our galaxy, the Milky Way. To understand this, we must first remember that our own sun is not stationary. It, along with its entire family of planets, asteroids, and comets, is hurtling through space at a tremendous speed, about 500,000 miles per hour. This incredible velocity is not random. It is the sun's orbital speed as it circles the supermassive black hole that lies at the heart of our galaxy. Our solar system is located in one of the spiral arms of the Milky Way, about 2/3 of the way out from the galactic center. And just as the Earth is constantly falling around the sun in its orbit, the sun is constantly falling around the galactic center. When the Voyager probes were launched, they were already carrying this immense galactic velocity with them. The speed they gain to escape the sun is actually very small in comparison to the speed at which the whole system is already traveling. So, while they are moving away from our sun, they are also moving alongside it on this much grander journey. They are now like tiny moons that have been released from their planet. They are no longer orbiting the sun, but they have entered their own, very slightly different, orbits around the galactic center. Their paths are now governed by the collective gravity of the hundreds of billions of stars, the vast clouds of gas and dust, and the immense halo of dark matter that make up our galaxy. They are now, in the fullest sense, citizens of the Milky Way, participating in the same great, slow, cosmic dance as every star we see in the night sky. This realization transforms our understanding of their journey. It is not a linear departure, but a transition from one orbital system to another, from the small local dance around our sun to the vast, majestic waltz around the entire galaxy. Now that we understand the Voyagers are in orbit around the galactic center, we must confront the timescale of this new journey. It is a scale of time so vast that it humbles all of human history into a mere blink of an eye. The time it takes for our sun, and therefore the Voyager probes as well, to complete one single lap around the Milky Way is approximately 225 million years. This immense span of time is known as a galactic year, or a cosmic year. Let us try to feel the weight of this number. 225 million years ago, when our solar system was last in this same position in its galactic orbit, the Earth was a very different place. It was the time of the early dinosaurs. The continents were merged together in the supercontinent of Pangaea. The first mammals were just beginning to evolve. All of human history, from our earliest ancestors to the present day, has taken place in just a tiny fraction of one single galactic year. The entire existence of our species is a brief season in this grand cosmic cycle. The Voyager probes are now embarked upon this journey. They will circle the galaxy, carried by the slow, inexorable currents of its gravity. They will witness, from their silent vantage point, the slow turning of the cosmic ages. The star patterns we see in our sky will slowly shift and change as our solar system and all the neighboring stars move along their own orbits. Nebulae where new stars are being born will dissipate, and new ones will form elsewhere. The probes are now participants in this slow, stately, and majestic procession. This timescale brings a sense of profound peace. The worries and urgencies of our daily lives, and even of our entire civilization, dissolve into insignificance when viewed against the backdrop of a single galactic year. The Voyagers have transcended human time. They now operate on cosmic time. Their journey is no longer measured in the years since their launch, but in the slow, patient, and recurring rhythm of their long fall around the heart of the galaxy. They are part of a process that began long before us and will continue long after we are gone. And as we rest and breathe, we can feel ourselves becoming a small part of that same patient rhythm, letting go of our own hurried sense of time and settling into the deep, quiet peace of the cosmic year. The orbit of our Sun and the Voyager probes around the galactic center is not a simple, flat circle, like a record spinning on a turntable. The distribution of mass in the galaxy is not perfectly flat. The stars, gas, and dust that make up the galactic disk have a certain thickness. As our solar system travels in its orbit, it is also gently pulled by the gravity of the material above and below the main plane of the galaxy. The result is a slow, gentle, wave-like oscillation. Our solar system bobs up and down, passing through the central plane of the galaxy, then rising above it, then falling back through it, and so on, over and over again. This gentle, rhythmic bobbing motion takes tens of millions of years to complete one cycle. It is like a horse on a cosmic carousel, not only going around, but also gently rising and falling as it travels. The Voyager probes are, of course, part of this motion as well. However, because of the trajectories they took when leaving our solar system, their oscillations will be slightly different from our own. Voyager 1 in particular was sent on a path that is taking it north or up and out of the main plane of the solar system. This means its oscillation through the galactic plane will be more pronounced. In the far future, millions of years from now, Voyager 1 will travel to a point high above the main disk of the Milky Way. From its vantage point there, the view would be spectacular. It would see the grand spiral structure of our galaxy laid out below it. A breathtaking Catherine wheel of stars. The density of stars around it would be lower, the interstellar space even emptier and quieter. It would then, over millions more years, be pulled back down by gravity, passing through the dense central plane and out the other side, before rising again. This slow, graceful and rhythmic dance up and down through the river of stars adds another layer of beauty and complexity to the probe's long journey. They are not just circling. They are weaving a slow and patient path through the very fabric of the galaxy. As the Voyager probes continue on their 225 million-year orbit, their journey will take them through different regions of the galaxy, each with its own character and density. The Milky Way is not uniform. It is a place of immense variety, with dense, brilliant star clusters, quieter and more sparsely populated voids, and vast, dark clouds of gas and dust where new stars are being born. The path of the Sun, and of the Voyager probes, will carry them through these different celestial neighborhoods over the course of a galactic year. For long periods, the probes may travel through regions much like our own, relatively quiet and sparsely populated with stars. The view would be a familiar one, a steady and unchanging field of distant lights. But at other times, their orbit might carry them closer to a star-forming region, a great nebula of glowing gas. The sky around them would be filled with the beautiful ethereal colors of ionized hydrogen and oxygen, and the brilliant, hot light of newly born blue stars. Or, their path might take them through the outskirts of a dense, ancient star cluster, where the sky would be thick with the golden light of old, cool stars. The background against which their silent journey unfolds will not be static. It will be a slowly changing cosmic landscape, a panorama that shifts and evolves over millions of years. The probes, of course, will be unseeing and unaware of these changes. But for us, in our imagination, it adds a richness and a texture to their voyage. They are not just traveling through empty space. They are traveling through a living, breathing galaxy. Their journey is a grand tour, not of planets, but of the galaxy's own diverse and beautiful environments. And as they pass silently through these ever-changing star fields, they are carried onward by the patient, gravitational rhythm of their long, slow orbit. A single lap around the galaxy takes roughly 225 million years. But as we have established, the Voyager probes, if left undisturbed, have the potential to remain structurally intact for 1 billion years or even longer. This simple fact leads to a profound conclusion. The probes will not just complete one galactic orbit, they are likely to complete many. They have embarked on a dance that could last for 4 or 5 full cosmic years, or perhaps even more. Let this thought settle. 1 billion years. 1 billion years ago on Earth, the first simple multicellular life was just beginning to form. The planet was a quiet alien world, with no plants or animals on its continents. 1 billion years from now, our sun will have grown hotter and brighter, and the Earth may no longer be a hospitable place for life as we know it. This is the timescale on which the Voyagers will now live their lives. They will circle the galaxy again and again, silent witnesses to the slow cosmic changes unfolding around them. They will complete their first orbit, returning to the general galactic neighborhood of their birth, only to find a solar system that is profoundly changed. They will continue on, beginning a second lap, a third and a fourth. This billion-year dance is the true scope of their potential journey. They have become, for all intents and purposes, artificial asteroids of the Milky Way, celestial bodies in their own right, participating in the long, slow and repetitive dance of galactic orbits. Their existence has become a serene, rhythmic pulse, a steady circling that will outlast civilizations, species, and perhaps even the Earth itself. This image of a long, repeating and peaceful dance is a comforting one. It suggests a kind of stability, a kind of immortality. But even this grand billion-year dance cannot last forever. There are other, slower and more powerful forces at play in the galaxy, forces that could, eventually, disrupt this peaceful orbit and lead to the final, uncertain chapter of the Voyager's story. After 1 billion years of peacefully orbiting the galaxy, the journey of the Voyager probes enters its final, most uncertain phase. We now contemplate the slow, powerful forces that could, over the very longest of timescales, disrupt their stable dance and lead to their ultimate, gentle disintegration. Just as the moon's gravity creates tides in Earth's oceans, the collective gravity of the galaxy creates what are known as galactic tides. These are subtle, differential forces that stretch and squeeze everything within the galaxy, including the Voyager probes themselves. A tidal force arises because the pull of gravity is not uniform over an object. The side of the object closer to the source of gravity is pulled slightly more strongly than the side that is farther away. For the Voyager probes, this means that the part of the spacecraft closest to the dense galactic center is pulled a tiny bit more forcefully than the part that is farther away. This creates an incredibly gentle, persistent stretching force along the length of the probe. At the same time, the gravity from the stars and matter in the galactic disk above and below the probe creates a gentle, squeezing force, compressing it vertically. These forces are infinitesimally small, far too weak to have any noticeable effect on a sturdy, metallic object over short periods. But the story of the Voyager's deep future is the story of infinitesimally small forces applied over immensely long times, over hundreds of millions, or even billions of years. This constant, gentle, tidal flexing could begin to stress the molecular bonds within the probe's structure. It is like bending a paperclip back and forth. If you do it once, nothing happens. But if you do it thousands of times, the metal weakens and eventually breaks. The galactic tides are a cosmic version of this process, a flexing that occurs on a timescale of a full galactic orbit. After thousands of such orbits, over many billions of years, this slow, rhythmic stress could potentially introduce microfractures into the probe's brittle, frozen structure. It is a force of slow, patient, and gentle unraveling. It is unlikely to be the primary cause of the probe's final demise, but it is one of the subtle, ever-present forces of the interstellar environment that will contribute to its eventual, peaceful decay. The most likely force to end the Voyager's long, stable orbit around the galaxy is the close passage of another star. We have already explored the nature of a very distant stellar encounter, like the one with Gliese 445, which will only provide a gentle nudge. But over billions of years of wandering, the probes will have countless such encounters, and it is statistically possible, though still very rare, that one of these encounters could be much, much closer. Closer. In this context, might still mean many times the size of our own solar system. But it could be close enough for the star's gravity to have a dramatic and decisive effect on the tiny passing probe. If a Voyager probe were to pass through the outer Oort cloud of another star, or even closer, the gravitational pull would be immense. Several things could happen. The probe could be captured by the star's gravity, its long galactic orbit transformed into a new, much smaller orbit around this new sun. It would become a tiny, artificial comet in an alien solar system. Depending on the trajectory of this new orbit, it might eventually spiral inward and be consumed by the star, a silent and fiery end. Or it could be flung into a stable, distant orbit where it would remain for eons. Alternatively, the encounter could have the opposite effect. Instead of being captured, the probe could be gravitationally ejected. The star's gravity could act like a powerful slingshot, accelerating the probe and flinging it out in a completely new direction and at a much higher speed. It could be ejected from its stable galactic orbit altogether, sent on a new journey into the vast, empty space between the galaxies, the intergalactic void. Its journey in the quiet of the Milky Way would be over, and a new, even lonelier journey would begin. The chances of any one of these events happening are small, but over 1 billion years they become a real possibility. A chance encounter with a passing star is the most powerful agent of change in the probe's deep future, the one event that could single-handedly rewrite its destiny. Another possible, though perhaps less likely, end to the Voyager's journey could come from its passage through one of the galaxy's great stellar nurseries, a giant molecular cloud. These are immense, dark and cold clouds of gas and dust, many light years across. They are the densest regions of the interstellar medium, and they are the places where new stars and planets are born from collapsing clouds of material. While the interstellar medium in general is a near-perfect vacuum, the environment inside one of these clouds is significantly thicker. The density of gas and dust, while still incredibly tenuous by any earthly standard, is millions of times greater than that of the surrounding space. If the long, wandering path of a Voyager probe were to, by chance, carry it into one of these great clouds, it would encounter a new force for the first time since it left our solar system: drag. As the probe sails through the denser gas and dust of the cloud, it would be constantly colliding with these particles. Each collision would steal a tiny, infinitesimal amount of its momentum. The cloud would act as a form of cosmic brake, a gentle but persistent headwind that would begin to slow the spacecraft down. This process would be incredibly slow. It might take millions of years of passage through the cloud to reduce the probe's velocity in any significant way. But if the probe were to become trapped in the complex gravitational fields within the cloud, its passage could last for a very long time indeed. Over these immense timescales, two things could happen. The constant sandblasting from the much denser dust in the cloud would dramatically accelerate the process of erosion, wearing away the probe's structure much more quickly than in the empty space outside. And the drag from the gas would continue to slow it down, causing its orbit to decay. It would slowly spiral in toward the densest parts of the cloud, where new stars are forming. Ultimately, its journey could end as it is incorporated into a new, forming solar system. The ancient, billion-year-old relic of our civilization could be vaporized in the fires of a protostar, its atoms recycled and mixed with the primordial material of a new generation of planets. Its long journey would end by becoming a part of something new. Its constituent atoms contributed to the birth of a new world, in a new time, in a distant part of the galaxy. This is a beautiful and poetic, if unlikely, end for our distant messenger. Whether it is through the gravitational disruption of a close stellar encounter or the slow breaking action of a molecular cloud, the ultimate fate of the Voyager's long, stable orbit is one of eventual change. The peaceful, repetitive dance around the galaxy cannot last forever. The galaxy is a dynamic and chaotic place on the longest of timescales, and the tiny passive probes are subject to its whims. Their journey is a beautiful illustration of what physicists call a chaotic system. We can predict its behavior with great accuracy in the short term for the next few 100,000 years. But over billions of years, tiny, unpredictable influences, the precise timing and geometry of a distant stellar pass, for example, can lead to wildly different outcomes. We cannot know for certain which of these fates awaits the Voyagers. Will they be captured by another star, flung into the intergalactic void, or gently disassembled in a stellar nursery. Their final destiny is a beautiful, serene unknown. But what we can know is that their current, predictable path is not their final one. The end of their orbit, the moment their long, stable journey is disrupted, is an inevitable event in their deep future. It is the moment their story transitions from one of peaceful, predictable travel to one of ultimate, unknowable dispersal. This gentle contemplation of the end of their stable journey is not a cause for sadness, but for a deeper appreciation of the immense and patient forces that shape the cosmos. It is a quiet acceptance of the fact that in the universe, nothing, not even a billion-year orbit, is permanent. And so, as we look to the very end of the Voyager's long story, we are left not with a clear and definite conclusion, but with a beautiful and serene uncertainty. We have followed the probes from their departure from Earth, across the boundary of our solar system, and on their long, silent cruise through the interstellar ocean. We have seen how they can endure for millions, and perhaps billions of years, slowly weathering in the cold and the dark. We have watched them complete many long, graceful orbits around our galaxy, and we have contemplated the gentle, powerful forces that will, one day, inevitably bring that stable journey to an end. The final fate of the Voyager probes is unknowable. They may, as we have considered, be captured by another star, or be flung into the lonely darkness between the galaxies. They may be slowly eroded into nothingness by the patient action of cosmic rays and dust. Or they may, in some far-flung future, be found by another intelligent species, their golden record finally delivering its ancient message. We cannot say which of these paths they will take. And in this uncertainty there is a profound peace. The probes have been released from our control, and now they have been released from our ability to even predict their destiny. They belong entirely to the universe now. Their legacy is not tied to their final destination. Their legacy was sealed the moment they were launched, the moment they began to send back their beautiful images and their priceless data. Their legacy is in the journey itself, not the arrival. And so, we can let go of the need to know the ending of their story. We can simply appreciate it for what it is, an epic, open-ended poem written across the canvas of space and time. As we prepare for our final reflections, we can hold this feeling of peaceful, uncertain wonder in our minds. The Voyagers are now, and forever will be, a part of the great unfolding mystery of the cosmos. Our journey with the Voyagers has taken us billions of years into the future. To find their ultimate end, we must now take one final gentle leap into a future so remote that the universe itself will be a different place, into the slow, quiet twilight of the cosmos. We now journey forward in time to an era so distant it is difficult to name with numbers. Let us travel to the far, far future, trillions of years from now, to a time when the universe has aged beyond recognition. This is the era of stellar exhaustion, the time when the last stars have finished burning their fuel and have begun to fade into darkness. For billions of years, the universe has been lit by the brilliant fires of stars, great fusion furnaces that forge heavy elements and illuminate the cosmos. Our own sun and all the stars we see in the night sky are part of this vibrant, star-forming era of the universe. But this era cannot last forever. Stars are born from great clouds of hydrogen gas. They shine by fusing that hydrogen into helium in their cores. But the supply of hydrogen in the universe is finite. Over trillions of years, all of this available gas will be used up. It will be locked away inside stars, or the dense, cooling remnants of stars. Star formation will slow down, and then, eventually, it will stop altogether. The last generation of new stars will be born, will live out their lives and will die. And then, there will be no more new stars. The universe will enter a new and final phase, an age of ever-deepening twilight. The existing stars will begin to burn out. The smallest, longest-lived red dwarf stars will be the last to go, sipping their fuel so slowly that they can shine for trillions of years. But even they will eventually exhaust their hydrogen and will fade into cold, dark embers. The universe will grow darker and colder. The brilliant, swirling galaxies will become ghostly collections of dead stars, black holes, and cold, wandering planets. This is the serene, quiet, and profoundly dark environment in which the Voyager probes will face their final, ultimate fate. The universe of their birth, a universe of light and warmth and life, will be gone, replaced by a universe of profound and eternal night. As the last red dwarf stars flicker and die, the universe will enter what astronomers call the degenerate era. The most common luminous objects left in the cosmos will be the cooling embers of stars like our own sun, objects known as white dwarfs. A white dwarf is the incredibly dense, hot core that a star leaves behind after it has exhausted its nuclear fuel and shed its outer layers. It is a sphere about the size of the Earth, but with the mass of a star, made of a strange, crushed form of matter called degenerate matter. When they are first formed, white dwarfs are incredibly hot and shine with a brilliant white light, but they have no internal source of energy. They are like cosmic coals taken from a fire, and they shine only by radiating away their leftover heat. This process of cooling is unimaginably slow. A white dwarf will continue to glow faintly for trillions of years, slowly fading from white to yellow to orange to red, until it finally becomes a cold, invisible object, known as a black dwarf, a dead star lost in the eternal darkness. In the far future we are now contemplating, the universe will be populated by these slowly cooling stellar ghosts. The faint, fading light of trillions of white dwarfs will provide the last illumination in the cosmos, a dim, ghostly twilight that will itself fade over unimaginable timescales. The Voyager probes, if they have survived this long, will be drifting through this final, fading glow. They will be ancient relics from a long-forgotten age of stellar light. They will have witnessed the final sunset of the universe. The environment around them will be one of supreme quiet and cold, a universe that is slowly, peacefully, and gracefully shutting down. The grand, dynamic, and vibrant cosmos of their youth will have given way to a silent, eternal, and ever-darkening night, populated only by the quiet, fading memories of the stars that once were. It is in this final, gentle twilight that the very matter of the probes themselves will face its final test. In the quiet, dark, and cold universe of the far future, with all the stars long since extinguished, we must now consider a force that operates on the longest timescale of all, the potential decay of matter itself. Our modern understanding of physics suggests that the particles that make up all the familiar matter in the universe, the protons and neutrons that form the nuclei of atoms, may not be truly stable. Some theories of grand unification, which seek to unite the fundamental forces of nature, predict that protons, over an almost incomprehensible timescale, can spontaneously decay into lighter particles and radiation. This process is called proton decay. This has never been observed. If it happens at all, the half-life of a proton is enormous, estimated to be at least 10 to the power of 34 years. That is a 1 followed by 34 zeros. This number is so large that it is, for all human purposes, infinite. The age of the universe today is a mere 10 to the power of 10 years. But in the truly deep future, in the endless, patient quiet of the degenerate era, even this incredibly slow process becomes the dominant force of change. If protons are indeed unstable, then everything we know, every rock, every planet, every dead star, is temporary. All matter is slowly, almost infinitely slowly, dissolving. Let us imagine the Voyager probe, having survived for trillions of years, drifting through the dark. It is made of atoms, and the nuclei of those atoms are made of protons and neutrons. According to this theory, one by one, over a period of time that makes the age of the universe seem like a fleeting instant, the protons that make up the probe will begin to decay. A single proton in one of the aluminum atoms of the main antenna might suddenly vanish, releasing a tiny puff of energy and other particles. 10,000 trillion years later, another one might go. It is the slowest, most gentle, and most fundamental form of unraveling imaginable. It is not a process of breaking or shattering, but of simply ceasing to be. The very substance of the probe, the very atoms that were forged in the heart of some ancient star, will slowly, peacefully, and silently dissolve back into the background energy of the universe. This process of proton decay, should it occur, would represent the final, ultimate end for the Voyager probes. After surviving for eons, After weathering the slow erosion of cosmic rays and enduring the profound cold of deep space, they will finally succumb to a force that is woven into the very fabric of their own being. Their end will not come from an external event, but from a slow internal dissolution. One atom at a time, the magnificent complex structure that was once a spacecraft will simply fade away. The aluminum of its antenna, the copper and gold of its record, the silicon of its computer chips, all will slowly, over unimaginable ages, evaporate into a thin, cold mist of radiation and elementary particles. There will be no final moment of destruction. There will be no memory of what was once there. The process is so gradual that it is more like a forgetting than a destruction. The universe will slowly forget that the Voyager probe ever existed. This is the most peaceful end we can imagine. It is not a violent end, not a tragic end, but a natural and fundamental return to the source. The atoms that were borrowed from the cosmos to create this beautiful machine will simply be returned to the cosmos. The probe will not leave a wreck, or a ruin, or a ghost. It will leave nothing at all. It will become one with the vast, cold, and quiet emptiness of the far future. Its long journey will be over, its substance given back to the universe that first gave it form. And as the last proton winks out of existence, the story of the Voyager probe, which began with a brilliant flash of fire and hope on a small blue planet, will end in the most profound and gentle silence imaginable. With the final, gentle dissolution of the probe's last atom, we arrive at the end of all things. The process of proton decay will not be limited to the Voyager probes. It will happen to everything. The cold, dead husks of planets, the cooling embers of white dwarfs, the dark cinders of black dwarfs, all will slowly evaporate into the darkness. The universe will enter its final state, an era known as the black hole era, where the only organized matter left will be the black holes themselves, which will also, over even more immense timescales, slowly evaporate through a process called Hawking radiation. Eventually, even the black holes will be gone. The universe will be left as a cold, dark, and unimaginably vast soup of photons, neutrinos, and other elementary particles. A universe in a state of maximum entropy, where no further change is possible. It will be a universe that has completely and utterly forgotten itself. There will be no memory of stars, of galaxies, of planets, or of the curious, fleeting life form that once arose on one of them and sent two small messengers out into the night. The story of humanity, and the story of our Voyager probes, will be over, not because it was lost or destroyed, but because the very medium in which a story could be recorded, matter itself, will have ceased to exist. This is a thought of profound and ultimate peace. It is not a tragedy, but a completion. It is the final, serene end of a long and beautiful journey. It is the universe returning to a state of simple, quiet grace. The story we have been telling tonight is a temporary one, a brief flicker of organized complexity in an eternal and patient cosmos. The beauty was in the flicker itself. The beauty was in the brief moment of life and curiosity that led to the creation of these wonderful machines. And as we let go of their final, distant fate, we can turn our attention back, one last time, to the meaning of their journey, not in the end of the universe, but for us, right here, right now. Having followed the physical form of the Voyager probes to their ultimate gentle dissolution, we now return from the far future. We come back to this present moment, to understand that the true journey of Voyager is not just one of matter, but one of meaning. The Voyager probes, as we have seen, are magnificent machines, triumphs of engineering and human ingenuity. They are built of metal and wire, of silicon and plutonium, but to see them only as physical objects is to miss their deeper, more enduring essence. The true significance of the Voyager mission lies not in the hardware that is currently sailing through interstellar space, but in the idea that it represents. That idea is one of pure, peaceful, and hopeful curiosity. It is the embodiment of a fundamental aspect of the human spirit, the desire to explore, to learn, and to reach out beyond our own horizons. The probes are a symbol. They represent a moment in our history when we looked outward, not with fear or with a desire for conquest, but with a simple and profound sense of wonder. The mission was not born of military ambition or commercial interest. It was born of a scientific and philosophical desire to see what was out there, to understand our place in the cosmos, and perhaps to let the cosmos know a little bit about us. This makes the Voyager probes different from many other human endeavors. They carry no weapons. They seek no resources. They claim no territory. They are simply messengers, ambassadors of a curious and hopeful species. This idea, the idea of peaceful exploration for its own sake, is in many ways more durable than the physical spacecraft themselves. The probes will, as we have seen, eventually erode, decay, and dissolve. But the idea they represent can be immortal, as long as there are conscious minds to remember it and to carry it forward. The story of Voyager, the tale of the two small ships sent to the stars with a message of peace, has become a part of our modern mythology. It is a story we tell our children, a story that inspires new generations of scientists, artists, and dreamers. And in this way, the journey of Voyager continues, not just in the silent darkness of space, but here, in our own collective imagination. The Voyager mission, launched in 1977, has become a defining landmark in the short history of human space exploration. Its journey and its discoveries have left a permanent echo in our culture and our understanding of the universe. Before Voyager, the outer planets were little more than faint, fuzzy disks in our best telescopes. We knew they were there, but we did not truly know them as worlds. Voyager changed everything. The images it sent back were a revelation. We saw, for the first time, the swirling, chaotic beauty of Jupiter's great red spot, a storm larger than our entire planet. We saw the intricate and delicate structure of Saturn's rings, a system of icy particles so complex and beautiful it defied all expectation. Voyager 2's continued journey to Uranus and Neptune gave us our first and, so far, only close-up views of these distant ice giants. We discovered new moons, new rings, and strange dynamic weather on worlds we had assumed were cold and inert. But perhaps the mission's most profound discoveries were made at the moons of these giant planets. We found active volcanoes on Jupiter's moon Io, the first ever seen beyond Earth. We saw the icy, fractured surface of Europa, beneath which we now believe lies a vast, hidden ocean of liquid water, a potential abode for life. At Saturn, we saw the thick, hazy atmosphere of Titan, a world with liquid methane rivers and lakes. These discoveries fundamentally reshaped our map of the solar system. They transformed it from a collection of 9 simple planets into a rich and diverse ecosystem of unique and fascinating worlds. The data sent back by the Voyager probes filled textbooks, launched careers, and laid the foundation for decades of future planetary science. The echo of the Voyager mission is present in every subsequent mission to the outer solar system, from Galileo to Cassini to Juno. It set the stage for our modern era of planetary exploration. And so, long after the probes themselves have fallen silent, their echo will continue to resonate through human history, a testament to the time when our eyes were first truly opened to the full, wondrous complexity of our own solar system. Beyond its scientific achievements, the Voyager mission has become a powerful and enduring symbol of something deeply important in the human character: hopeful curiosity. In a world often driven by conflict, division, and short-term thinking, the Voyager story stands as a quiet reminder of what we can achieve when we are motivated by our better natures. The creation of the probes and their golden records was an act of looking far beyond the immediate problems and concerns of the day. It was an investment in the deep future, a project undertaken not for immediate gain, but for the expansion of knowledge and the expression of a philosophical hope. The curiosity of the Voyager mission was pure. It was the simple, childlike desire to know, what is there? It was the same curiosity that drove the first humans to explore new lands, the first sailors to cross unknown oceans, and the first scientists to peer through a telescope. It is a fundamental human drive, and the Voyager mission is perhaps its most elegant and ambitious expression. The probes were sent on a mission of discovery, not exploitation. They were our eyes and ears, sent to observe and to learn in a spirit of peaceful inquiry. This is a powerful and important legacy. And this curiosity was tinged with a profound sense of hope. The very act of placing a message on board the golden record was an act of hope. It was hope that the message might one day be found. It was hope that if it were found, it would be understood as a gesture of peace. But most profoundly, it was a hope for humanity itself. The record presents a beautiful and idealized portrait of our world. It shows a planet of natural beauty, of diverse cultures living in harmony, of creativity and intelligence. The team that created it chose to show the best of us. They chose to send a message that said, "This is what we aspire to be." In this sense, the Golden Record was as much a message to ourselves as it was to any potential extraterrestrials. It was a reminder of our own potential for peace, for creativity, and for wonder. And as the probes carry this hopeful message on their endless journey, they serve as a constant, quiet inspiration, a symbol of our own capacity to reach for the stars, both literally and metaphorically. The impact of the Voyager mission cannot be measured solely by the data it collected or the images it returned. Its true impact is in the ripples it has sent out through our culture, inspiring countless individuals and shaping our collective vision of the cosmos. For the generation that grew up watching the Voyager encounters unfold on the evening news, the mission was a formative experience. It made the universe a tangible, accessible, and wondrous place. The strange, beautiful worlds it revealed became a part of our mental landscape, firing the imaginations of future scientists, engineers, writers, and artists. How many people working at space agencies around the world today were first inspired as children by a stunning Voyager photograph of Saturn's rings? How many science fiction novels, films, and works of art have drawn inspiration from the mission's journey or the philosophical questions posed by the Golden Record? The ripple effect is immeasurable, but it is undeniably vast. The mission's most famous single image, the pale blue dot photograph taken at the suggestion of Carl Sagan, has had a particularly profound cultural impact. This tiny pixel-sized image of Earth, seen from 4 billion miles away, has become an iconic symbol of our planet's fragility and our shared responsibility to care for our only home. It is an image that has launched 1,000 environmental campaigns, 1,000 poems, 1,000 sermons on humility and perspective. This is the ongoing legacy of Voyager. It is not a static collection of historical facts, but a living, breathing influence that continues to shape how we see ourselves and our place in the universe. It is a story that continues to generate new ideas, new art, and new science. The initial act of discovery, of sending those 2 small probes out into the dark, has created a wave of inspiration that continues to wash over us, decades later, and will likely continue to do so for many generations to come. And so we arrive at a peaceful and comforting conclusion. The physical journey of the Voyager probes will one day end, whether in billions or trillions of years. But the journey of the idea of Voyager, the journey it takes in our minds, can be an unending one. As long as we continue to tell its story, to reflect on its meaning, and to be inspired by its example, the mission is never truly over. The probes themselves are now too far away to see, their voices growing ever fainter. But they have left behind something that does not fade, a powerful narrative of exploration, hope, and wonder. This narrative invites us to travel with them in our imaginations. On any quiet night, when we look up at the stars, we can remember that 2 small, silent pieces of our world are out there, sailing through that vast darkness. We can follow them in our thoughts, imagining their long, patient journey through the interstellar ocean, their distant encounters with other stars, and their billion-year dance around the galaxy. This mental journey is a powerful form of meditation. It allows us to step outside of our own small concerns and to connect with something vast, timeless, and beautiful. The Voyager probes have become more than just spacecraft. They are points of focus for our own cosmic curiosity. They are invitations to dream. They have given us a foothold in the interstellar ocean, a place for our minds to wander. And in this way, their journey will continue for as long as we do. It will be relived and reimagined by every person who hears their story and is moved by it. The metal and wire may be temporary, but the wonder it has inspired is a renewable and potentially infinite resource. The most enduring legacy of Voyager is not the object, but the awe. And that is something that can travel forever. As we draw our journey to a close, let us settle on a final, serene image of the Voyager probes. Let us see them not as active explorers, but as silent, passive witnesses, carrying the memory of their creators on an endless, wandering path. Imagine the Voyager probe in the very distant future, 1,000,000 years from now. It is a cold, silent, and weathered object, drifting through the starfields of the Milky Way. By this time, it is no longer a piece of cutting-edge technology. It is an ancient artifact, a relic from a long bygone era of history our own. It is a product of the very infancy of space travel, a time when a young species first learned how to leave its home planet and venture into the cosmos. To any hypothetical civilization that might find it, it would be an object of profound archaeological significance. It would be like us discovering a perfectly preserved sailing ship from a lost, ancient civilization at the bottom of the ocean. Its design would speak of its primitive origins. Its computer systems, which were state-of-the-art in the 1970s, would seem impossibly simple. Its data storage, an 8-track digital tape recorder, would be a quaint curiosity. Its power source, the RTG, would be long, cold, and inert. The entire object would be a time capsule, not just of the sounds and images on its record, but of the technology and the thinking of the time it was built. It is a snapshot of who we were and what we were capable of in one particular moment. This perspective gives us a gentle sense of humility. Our greatest achievements will one day be ancient history. The things we see as modern and advanced will, with the passage of enough time, become primitive artifacts. The Voyager probe, in its long future, embodies this truth. It is a piece of our present that is destined to become a piece of the deep past. As it drifts silently through the ages, it is a quiet and humble representative of our era, a single, lonely artifact from the dawn of the space age, preserved in the cold, dark museum of the galaxy. As the Voyager probe drifts through the interstellar ocean, it is, in a very real sense, one of the rarest and most improbable objects in the entire galaxy. The universe is filled with natural objects, things formed by the patient and impersonal laws of physics. There are stars, planets, asteroids, and clouds of gas. These are all beautiful and wondrous, but they are the products of gravity and nuclear fusion, of chemistry and thermodynamics. The Voyager probe is something different. It is an object of intelligence. It is a piece of matter that has been deliberately and carefully arranged in a highly complex and non-random way to perform a function. Its structure is not the result of a crystal growing or a planet accreting. It is the result of a thought. Its intricate wiring, its carefully shaped antenna, its complex instruments. All of these are the fossilized remnants of human consciousness. In a galaxy of trillions upon trillions of natural objects, a piece of manufactured technology is an object of supreme rarity. It is a whisper of order in a universe that tends towards disorder. It is a small, temporary defiance of entropy. To any civilization that might find it, this would be its most astonishing quality. The fact that it is not a rock, that its form is clearly artificial, would be a discovery of monumental importance. It would be proof that they were not alone, that at least one other time, in one other place, a mind had arisen that could manipulate matter and send a piece of itself out into the cosmos. We do not need to imagine that the probe will ever be found for this idea to have a peaceful and profound effect on us now. Simply knowing that this rare and precious object exists, that a small piece of human thought is physically present in the interstellar void, is a source of quiet wonder. It is a testament to the strange and beautiful improbability of intelligence itself. Even if the golden record is never found or never deciphered, even if the probe's technological origins are never understood, the Voyager spacecraft itself, by its very existence, carries an undeniable message. It is proof. It is a single, unambiguous data point in the great cosmic question of whether life exists beyond Earth. The probe is an undeniable biosignature. Its complex, ordered structure is so statistically unlikely to have formed by chance that its artificial nature is self-evident. It is a fossil, not of a biological organism, but of the process of life and intelligence itself. Life is a process that creates order. It takes the simple, disorganized materials of its environment and arranges them into complex functional structures. A tree takes sunlight, water, and carbon dioxide and creates the intricate order of a leaf. A bird takes twigs and grass and weaves the complex structure of a nest. Humanity, as a part of this terrestrial biosphere, has simply taken this process one step further. We have taken the refined metals and minerals of our planet and have arranged them into the even more complex and ordered structure of a spacecraft. The Voyager probe is a direct extension of the same fundamental ordering principle that gives rise to a flower or a seashell. Therefore, the probe itself is a memory of life. It is carrying the ghost of the terrestrial biosphere out into the galaxy. Its very atoms, forged in stars, were once a part of our planet's geology. They were mined, refined, and assembled by living beings, by the hands and minds of a species that was the product of 4 billion years of evolution on a small, watery planet. The spacecraft is a physical embodiment of that entire long story. It is a piece of Earth, a piece of our life given to the stars. So, as it drifts in the silent darkness, it is more than just a machine. It is a testament. Its existence is a quiet declaration that once, in this small corner of the galaxy, a planet came alive, and that life, in its boundless and creative curiosity, eventually found a way to reach beyond its own shores and touch the void. The probe is the fossilized footprint of that momentous achievement, a silent but powerful witness to the fact that the universe is not sterile, that at least once it woke up and wondered. As the Voyager probe continues its long, silent journey, it can be seen as a ghost. Not a frightening or malevolent ghost, but a gentle and quiet one. It is the ghost of the intelligence that created it. It is the disembodied remnant of the collective mind of the thousands of scientists and engineers who designed it, built it, and guided it on its journey. All of those individual human minds are or will be gone. But the product of their thoughts, the physical manifestation of their shared intelligence, sails on. The probe haunts the star lanes not with any purpose or intent, but simply by being there. It is a quiet spectre of a moment of profound creativity and ambition. It is a memory of a time when a species was able to marshal its intellectual resources to achieve something beautiful and lasting. This image of the probe as a gentle ghost is a peaceful one. It is disconnected from the noise and urgency of our world. It has transcended the lives of its creators and has become something timeless. It is the enduring echo of a thought that said, "Let us go and see." This ghost is not just a ghost of human intelligence, but of the very possibility of intelligence. It is a quiet suggestion, drifting through the darkness, that minds can arise from matter, that the universe can become aware of itself. In its silent passage from star to star, it is a constant, though almost certainly unseen, reminder of this remarkable potential. It is a peaceful, wandering spirit, a testament to the brief and beautiful flame of consciousness that once burned on a distant, pale blue dot. Bringing these final thoughts together, we arrive at a profound and humbling possibility. It is entirely possible that the Voyager probes and their golden records will be the last surviving evidence that humanity ever existed. Our civilization is a fragile thing, confined to the surface of a single, vulnerable planet. Over the immense timescales of cosmic history, there are many things that could bring our story to an end. But the Voyager probes are already beyond the reach of any terrestrial catastrophe. They are safe in the vast, stable environment of interstellar space. They are, therefore, our last and most enduring emissaries. They carry our story, our music, our science, and our hope, encapsulated in a form that is designed to last for 1 billion years. Long after our sun has swollen into a red giant and consumed the Earth, the Voyager probes will likely still be sailing on, intact and serene. They are our final legacy. This is a thought that can bring a deep and profound sense of peace. It means that, in a very real sense, a part of us will not be lost. A small piece of our world, a small echo of our existence, will continue on, woven into the fabric of the galaxy. The probes are our final representatives, carrying a message of peace and curiosity on our behalf to a future we will never see. They are the quiet, humble, and incredibly patient ambassadors of a world called Earth. And as they continue their silent, endless journey, They fulfill this final, solemn duty with a simple and elegant grace. By simply continuing to exist, they are the last of us, and their journey is eternal. Our long journey is now drawing to its close. We have followed the Voyagers across space and through time, to the very end of all things. Let us now, in these final moments, gather these threads together into a single, peaceful reflection on their meaning. Let us reflect one last time on the sheer wonder of the Voyager's journey, from its beginning to its far-flung future. It began as a fleeting thought, an idea in the minds of a few creative and brilliant people. It was a plan, a sketch on a blackboard, a complex calculation of orbital mechanics. It was a dream of a grand tour of the outer planets, taking advantage of a rare celestial alignment that happens only once every 176 years. This fleeting, intangible idea was then slowly, carefully, and painstakingly transformed into physical reality. It became two magnificent machines, built by human hands, infused with the collective knowledge and skill of a generation. Then, in 1977, with a great and fiery burst of energy, these machines left our world and began their journey. They were, for a time, our active servants, our eyes and ears in the distant solar system. They dutifully followed our commands and sent back a treasure of knowledge that remade our understanding of our own cosmic backyard. Then, their primary mission complete, they began a new phase, a long and quiet journey into the unknown. They crossed the invisible boundary into interstellar space, their faint voices whispering back to us the secrets of the void. Soon those voices will fall silent, and their journey will enter its longest and final phase. They will become eternal wanderers, silent ghost ships on a billion-year voyage. They will outlast their creators, their homeworld, and perhaps even the stars in the sky. From a simple, fleeting human thought to a near-eternal cosmic object, this is the breathtaking arc of the Voyager story. It is a journey that connects the ephemeral nature of a single human idea to the vast, enduring timescale of the cosmos. And in that connection, we can find a sense of our own profound, if brief, significance. We are the creatures who can have such thoughts, who can dream such journeys, and who can, on rare and beautiful occasions, make them real. If the journey of the Voyager probes teaches us one single lesson, it is the lesson of patience. Our human lives are lived in a rush. We measure our days in hours, our years in seasons. We are accustomed to a world of fast communication and immediate results. The universe, however, operates on a different clock. Its rhythms are slow, deep, and majestic. The Voyager probes in their long journey have become fully attuned to this cosmic patience. Their conversation with Earth is already a slow one, with a round-trip time of nearly 2 days. Soon, it will cease altogether, and they will enter a state of pure, uninterrupted travel that will last for eons. Their journey is a quiet meditation on the power of slow, persistent, and gentle processes. They will be eroded not by a sudden impact, but by the patient, atom-by-atom sputtering of cosmic rays over millions of years. Their path will be altered not by a powerful, sudden thrust, but by the cumulative, gentle nudges of gravity from countless distant stars. Their final end will come not in a great explosion, but in the almost infinitely slow dissolution of matter itself over trillions of years. To contemplate this journey is to learn to breathe more slowly, to let go of our own sense of urgency, and to find peace in the patient, unhurried unfolding of the cosmos. The Voyagers teach us that the most profound journeys are not the fastest ones. They teach us that endurance, persistence, and patience are the great virtues of the universe. They invite us to align ourselves with this deeper, slower rhythm, to find a sense of calm and perspective that can only come from contemplating the vast and patient timescales of the stars. In a hurried world, the story of Voyager is a beautiful and necessary reminder of the deep, abiding peace that can be found in the slow and steady passage of cosmic time. As we prepare to let the story of the Voyagers drift into our dreams, let us hold on to one final, powerful, and deeply comforting thought. As long as these two small spacecraft continue to exist, a physical piece of us will always be out there, among the stars. They are more than just machines we have built. They are extensions of ourselves. They were born of our minds, built by our hands, and launched from our world. They carry our music, our languages, and our images. They are, in a very real and tangible sense, a part of us. In all of human history, and in all of our own personal lives, we are accustomed to the idea that things end, that things are lost. We say goodbye to people, to places, to moments in time. The things we build on Earth will eventually crumble and turn to dust. But the Voyager probes have, in a way, escaped this fate. They have achieved a kind of terrestrial immortality. By being sent into the vast, stable, and empty environment of interstellar space, they have been placed in a realm where they can endure for a timescale that is, for all human purposes, forever. This means that our connection to the cosmos is no longer just one of observation, of looking up at the stars from a distance. We now have a physical presence there. We have a tiny, silent anchor in the great cosmic ocean. When you look up at the night sky, you can know with certainty that a part of your world, a part of your human family is out there, drifting silently through that beautiful darkness. This thought can be a source of immense comfort and a deep sense of belonging. It connects us to the universe in the most direct way possible. We are no longer just looking at the cosmos. We are a part of it in a new and profound way. A piece of our home, a piece of our story, a piece of us, is now and forever on a journey through the stars. The story of the Voyager probes is, in the end, a story without a final chapter. Will their message ever be found? We will never know. What is their ultimate, final destination? We cannot predict it. Their journey ends for us in a gentle, peaceful, and unanswered question. And there is a profound beauty in this. So much of our modern world is about finding answers, about solving mysteries, about having complete and certain knowledge. But the Voyager mission invites us to embrace the beauty of the unknown. It suggests that the value is not always in the answer, but in the asking of the question itself. The question asked by the Voyager mission was a simple one. Is anybody out there? The golden record was our way of asking it. The fact that we will never receive a reply does not diminish the value of having asked. The act of reaching out, the gesture of cosmic hope and curiosity, is a beautiful and meaningful thing in its own right, regardless of its outcome. It speaks to the best parts of our nature. To find peace in an unanswered question is a deep form of wisdom. It is an acceptance of our own limitations, and an embrace of the vast mystery of the cosmos. The Voyagers are now a permanent part of that mystery. They have merged with the great silent unknown that they were sent to explore. And as we let ourselves drift towards sleep, we can find a deep calm in this lack of resolution. We can let go of the need for an ending. We can simply appreciate the story for the beautiful, open-ended poem that it is. A question whispered into the void, destined to echo, unanswered for eternity. Our gentle journey following the Voyager probes is now complete. We have traveled with them from their home, out to the edge of the sun's influence, and into the vast interstellar sea. We have followed their path for billions of years, to the very twilight of the universe. And now, we return to the quiet of our own rooms, to the comfort of our own beds. But the journey does not have to end here. The story of Voyager is, above all, an invitation to dream. The probes are now out there, sailing on in the silent darkness. And they will be there tomorrow night, and the night after, and for all the nights to come. They have given us a permanent place in the cosmos for our imaginations to wander. They are a constant, gentle reminder of the vastness and the wonder that lies beyond our small world. They invite us to look up at the stars and to feel a sense of connection, a sense of participation in the great, unfolding cosmic story. So, as you let go of the day and prepare for sleep, allow your own mind to drift out into that peaceful, starry darkness. Let your thoughts wander alongside those two silent, hopeful ships. Feel the immense quiet, the profound peace, and the patient, endless nature of their journey. Let their story be a gentle reminder that the universe is not a distant, abstract thing, but a vast and beautiful home, that we are a small but wondrous part of. The Voyagers are our dream of exploration, made real. And now, they are a dream that you can return to, anytime you wish, as you close your eyes and drift into your own peaceful, quiet slumber. Tonight, We have journeyed with two small ships on the grandest ocean of all. We have felt the deep quiet of interstellar space, the patient rhythm of cosmic time, and the enduring hope of a message in a bottle. We have seen that their voyage transforms a fleeting human idea into a near-eternal presence among the stars. This quiet story reminds us that we are not separate from the cosmos, but a thinking, feeling part of it, capable of reaching out with curiosity and grace. As long as the Voyagers sail on, a piece of our world, a piece of us, will forever be part of the great silent dance of the galaxy. Now, it is time to let this story go. You have listened long enough. You have permission to let go of these words, to let go of all thought, and to drift into the deep, restorative peace that awaits you. Allow the gentle current of sleep to carry you away. Sleep now, sleep deeply and peacefully. When you dream of space, what colors do you see? There is no right or wrong answer. Simply notice what comes to mind. Thank you for sharing this quiet time with me. If this journey helped you relax, a simple like or subscription helps us create more peaceful voyages for others to enjoy. The cosmos is always here, waiting with another story. When you are ready for your next gentle exploration, our full library of cosmic narrations is here for you. For now, simply rest,